So welcome to this video and welcome to this course. My name is Daniel Possible Kwabi and I'm a software engineer. Well, obviously, otherwise why else would I be here trying to teach you Python? And in light of that, that's exactly what we are going to do. So this is a full Python course. Now, if you're starting from absolute zero, or if you've ever tried to learn to code and you just didn't understand the concepts, or you just burnt out, or you ended up in tutorial hell, I want you to watch this video. This is the right video for you, as I have taken my time to explain everything to your understanding. Now we are going to cover basically everything, so from data structures to error handling and to functions and to strings, lists, whatever you can think of, we have probably covered that in this course. Now this course is going to be a marathon. That means it's going to take a very long time. And mind you, this is not a TV show that you're watching. These are academic, these are educational concepts. This consists of your fundamentals of programming, depending on who you ask. And I'm going to break down the whole course in the description. Okay, I'm going to leave a lot of timestamps for you to be able to navigate. Like I said, even if you've started learning already, you can just navigate over there like that. Yeah, you can pause it, you can rewind it, you can forward it. It all depends on you. At the end of the day, my goal is that you understand whatever it is that we are doing. And if your code breaks, don't stress it out. Write me a comment. I'm going to be of assistance to you. Alright, so before we can get to the fun part, and that's of course building the games, the absolute foundation of all programming, and that's data types and then our variables. If you want a computer to do anything, you have to give it information to hold on to. Now think of variables as labeled boxes where we are going to be storing that information. But we aren't just going to look at boring theory. We are going to learn how to create these boxes, put data inside them, and immediately use them to build your first two real tools, a nickname generator and a simple interest calculator. Like I promised, this is going to be a lot of fun. So right off the bat, we are going to be building these two mini projects.
At the end of this module, you should have installed Python, set up your VS Code, and then written your first script and taking your first step towards learning the language. So to write our first script, we are going to need something we call a print statement. Now you may ask, what's a print statement? So a print statement, as a sound, is just going to give us an output based on an input that we are given. You understand? So if you think of a printer, once you want to print something and you are inputting some specific documents, you see, you expect a certain output. That's just how our print statement works. So for our print statement, it's just like a printer. You see, whatever documents that you put in, you ideally expect that particular output, right? Yes, so that's how our print statement also works. You understand? Now for our first program, we can go in here and just see hello world. Like this, very beautiful. Yes, so now you have been able to do this. You have officially written your first Python script. Now I'm not going to talk much about the quotation marks and all of that, but you officially have your first Python script. Understand? Yes. Now how do we run this script? Yes. So when we are done writing this line, we can basically click the button that looks like play over here. Now when we click this, we are going to run and we can see that we have hello world. I'm going to highlight it. You see, the input we gave has been returned. So our print statement returned the exact input that we gave, like I said it would. Yeah, so that's print statement. And congratulations once again for running your first script in Python. Now, very important, in order to not run into errors, in order to be error-free in the future, we have to tackle a very important concept over here. You understand? Yes. And now to do that, I'm going to print another thing to the console. So hello world. Yes, 2. Again. So at this point, you realize that whatever input is in between the quotes is going to be returned. That's the output that we are going to get, because that's what we have written over here. Yes. So now we are going to understand our white spaces in a minute, but let me run again. So when we run this again, we have gotten both statements right perfectly, and there were no errors. right? Now let me space it over here, just one single space. And you can already see that VS Code is giving us a warning. You can see the sign over there that this is something bad, and we are going to see why in a minute. Yes. So if you come to the bottom here, you see that we have an indentation error, unexpected indent. You understand? Yes. Now this unexpected indent is due to our white space over here. Now white space is just any space. You understand? Yes. So because of this space over here, Python is putting this under this. You see, it's putting this in scope of this. You see, now you realize that in other languages, they have points where they have brackets like this, and then they have the curly brackets to like this. You see, now all this is to control scope. You see, now in Python, we don't do any of that stuff. This is how we control scope through indentation. So it's kind of like how when you're writing an essay, you do paragraphs. So whenever you put something like this, you see, you're adding an indent. You see, now we'll talk more about indentations in the future and what they do. You see, they are useful. They are not some danger you have to be, or you have to be afraid of them and get used to them too. But yes, they have specific uses, and then we'll be using them for that in the future. Yes. So that's white spaces and then indentation. Yes. So anytime you see an indentation error in your code, quickly go and then check your spacing and then all of your syntax, and then you'll be cool like that.
Now, at this point in the course, I believe you have already printed your first hello world, okay? And that was just a little example of how to work with text, okay? That's how to work with text. But that is not the full story, okay? Let me tell you a massive secret about real-world software engineering. About 80% of back-end development is just moving, cleaning, and manipulating text. Now, whether you're routing data for a transport platform or handling user profiles for a learning management system, you are constantly dealing with messy string data. So in this module, we are mastering text. You are going to learn how to extract pieces of data using indexing and slicing. We'll cover string methods to instantly clean up user inputs and formatting so programs can actually communicate dynamically. If you want to handle real data, you need to master this. Let's jump right back in.
So welcome to module 1 of this course, where we are going to be looking at data types and variables. Now let's think of data types as a way to label our variables. You understand? So these are the data types that we have in Python. Now we have integers. Now integers, floats, strings, and booleans. Now we are only concerned with these four for this lesson. We are going to tackle the rest as we move on. Yes. But I just added it so that we know of them, that they exist. And then we'll know that they are there. So I'm going to delete this. You can take a moment, you can pause and read through if you are really interested. But we are going to move in this respect right here. All right, so integers, floats, strings, and booleans. IFSB, IFSB, IFSB. All right. Now integers are numbers without decimal points. So if I come here and I write 4, 4 is an integer, right? If I make it 45, 45 is still an integer. It's still satisfying the conditions. There are no decimal points. I can go ahead and make it 456, and it's still the same thing. It is an integer. It is still satisfying the conditions, right? Yes. Now we can deal with floats. Understand? Now the next data type we have is a float. Yes. Now floats are numbers with decimal points. Floats are numbers with decimal points. So if I write 7, now 7 is an integer, right? But if I say 7.6, this now makes 7.6 a float. So this changes from the data type integer to the data type float. Understand? Now strings are just text, plain text. Yes. So now this is a string. The hello world that we have been writing, this is a string. So this is a string. And now we have booleans. Now a boolean is any expression that evaluates to true or false. So it's a question that evaluates to true or false. So for example, are you a student? It's either you're a student or you are not. Are you a boy? It's either you're a boy or you're not. So you're a boy will be true or what? False. So are you X? True or false? It's a yes or no response. So yes here equating to true, then no equating to false. Yes. So I'm just going to leave it at that. True. Let me write true over here. That's a boolean. This is a boolean. So a boolean can be either true or false. So now we have some data types. Now, in order to work with our data types, we have to do something very important. Right now, I don't know if you can see, we have all these error lines, not defined, and blah, 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 a whole lot of errors, you understand? So what we have to do something with these, our data types, right? Yes, now I'm going to highlight over our hello world again. As you can see, it says hello is not defined. And once again, our white spaces. So because of the white space, these have been separated. So hello is one word, and the world itself is another word, right? Yes. Now, in order to change the status of this to be defined, what we need is a variable. You understand? Yes. Now, this variable is going to store our data type. It's that simple. We are going to store our data in the variables. So think of our variables as a place to be storing our data. Yes. Now I'm going to create a new string data type right below this. So we see name is equal to, I don't like John, let's say Daniel, right? Daniel Smith. Sounds fun. Yes. Now what is the difference between this hello world over here and then this Daniel Smith over here? Now the difference is that this is a string. And now these are not separate words. It's just a sentence, or if you may, a sentence like that, because it's in between these quotes over here. You see. So I'm going to come back here and place these two in quotes, and it should be safe. Yes. Now, when you do this, you see, you can actually have your data types, and then without passing them to any variables, and you're actually not going to get any errors because it can be done. Like I said, if you watch the Tech from Zero series, like I said, you have to envision the computer as being really dumb in order to get somewhere with our programming. You understand? Yes. So it's just a tool. Programming is just a tool for us to do what we want to do. Yes. So now I'm going to create another variable. I'm going to be calling it age. Hell no, I'm not 30, but yes, I'm not about to tell you my age. So all right. So we can say our age is equal to 30. Yes. Now this is just an integer like this one over here. The only difference is that this has been passed to a variable. This has been stored inside our age variable. So now wherever we see age is 30, hence the equal to C. So if A is equal to B, A is B, so age is 30. So instead of writing 30 every time we want to work with our age, we can just write age. I hope that makes sense. Now what we want to do next is we'll say GPA. No, so now GPA comes in decimals, right? That's a different way we can represent our floats, you see. Yeah, so now this is like a practical way in which you can use all this stuff, you see, programming. We can use our tools, our data types that we have. And then lastly, for a student, you can say true. You see, actually false or true. You true. So a student is equal to true. Like I said, it's either you're a student or you're not a student. All right. Yes. Now this over here, I think it's actually going to throw an error. I'm going to get rid of the line. Divide true by false. And we are going to do all the operations later. Yes. And now for some little confirmation. So it's not like I'm lying to you or something. Let's print. Let's print. Let's print. Let's print name, right? And then let's print age, let's print GPA, and let's print student. Yes, so we are going to be printing all of this. So I'm going to run over here. Yes, and as you can see, my name is Daniel Smith, my age is 30, my GPA is 3.5, and I am a student. You see our output to the console like that. Yes, which means whatever we did worked, right? Yes. Now we can do same over here, right? I'm going to print this, just this one. I want to do a little demonstration, right? Yes. Okay, so if you do that, you are going to print 4, 5, 6, you see? Yes. So like I said, this is not going to actually show you any error, you see? But instead of saying Daniel Smith, anytime we wanted my name, imagine I have one of those error names, like very long, like that. Are you going to type it every time? You see? So that's one advantage of variables themselves. Now finally, let's print out the type. And again, you might find this useful as you program, that you may have to check some of these things. So like this. All right. Yes, so let's print the type of everything. So that it's not like I'm lying to you or something, see. And let's print a student, right? Like this. And let's get rid of all of this. Okay, so now we are good to go. So now I'm going to check the type of all of these and we'll see if I lied to you or I didn't lie to you. Yes. So we can see that we have our string, that's our name is a string. Then our age is an integer. And then our GPA is a float because of the decimal, of course. And then our boolean, like I said, evaluates true or false. So that's the expression. Now we can do something very fun again. Yes. So now we know that we perform mathematical operations on numbers, right? Yes. So if you do not want to perform mathematics on the number, maybe it's part of someone's name tag, maybe they are playing Squid Game or something. It's part of their identification. You don't want to perform mathematics with it. You can just simply come and then you cast. Yes. So because we do not want to perform mathematical functions with this, we are going to do something that we call a cast. You see, we are going to cast. Now let me explain the cast, right? You see, like just like the cast of a film or a movie, they are playing different roles. You see, they are not actually that. So Vin Diesel is not actually dumb in real life. If he tries all that nonsense he does with the car, he's going to die. You see, but yet still he gets to play that role for the setting of the movie. Yes, so now we are going to give this our 456 an identity to play. You see? So now we can say str and then we put it in the brackets again for scope. So everything in the brackets is going to be cast as a string. And now this is going to create its own data type, right? So if we do something like this, now we want to store it in a variable. You see, so we can see casted number. I'm going to call it that. Yes, I know, very creative, but yes. So we say casted number is equal to this, and then finally we can come and print the type of our casted number. I'm going to comment some of these out so that we are going to see very clearly exactly what is going on. All right, so I'm going to hit run and hopefully we have no errors. Let me get rid of this string too. Yes, so we run, and yes, so we can see that we successfully changed it from an integer into a string. Yes, so now that's how to cast also in Python, which you might find very useful in your journey. Yeah. So that's pretty much it for module 1. See you in the next one. Now next up, with all that we have learned today, we are eligible to build some projects right. Yes. So in the next module, in the next section, we are going to be building some projects, some very simple projects to kind of understand the flow of programming and everything. So stay tuned. Now in this module, I'm going to take you through some basic operations in Python. Now by basic operations, I just mean some mathematical operations, because we'll be required to use mathematics a lot as we go through our coding journey. So first of all, we are going to look at addition. Now addition stays the same even in programming. We just have to wrap it around in some good syntax. Same for subtraction, same for multiplication, and even division. And for division, we have a little variety over here. We'll get to that in a minute. And finally, exponentiation over here. So to perform addition in Python, we simply have to write out what you want to add. So in Python, plus does the same thing mathematically. So mathematically, this we know that this is going to evaluate to 5. Now we can do some subtraction. So for subtraction, let's say 5 minus 2. Then we can do some multiplication. And for that, let's say 3 star 4. Yes. So as you will realize, things are looking a little bit different. Now in Python and in programming languages as such, for multiplication, we're usually going to use the asterisk. That's how we represent multiplication in Python. Now for division, yes. So the first type of division that we are going to find is float division. So for float division, this is how we are going to represent it. So we just do the division by our forward slash. We just do the division by our forward slash. And at this point, I think we should start printing some results. Again, print helps you to get your output. So I'm going to run this. Yes, now this is float division. Now, right in the previous lesson, I showed you that this particular data type deals with decimals. Hence, also float division. We are going to be returning a lot of decimals. Now, let's look at integer division. I'm going to remove the print line over here. And now let's print this. Let's get our output. So I'm going to run this again. Now you can see for this, we just returned 1, right? Yes, now I'm going to explain this. You know what, to help me explain it better, let me just print the same thing up here using our float division. And now let me run it again. Yes. Now by running this, you can see that the first one, our float division, returned the recurring decimals. See? Because 4/3 is a recurring fraction, right? Yes. But with our integer division, we are basically stripping away all this part. And the only thing we care about is this, our 1. So we want nothing to do with our decimals for integer division. Now finally, we have modulo division. Now for modulo division, the sign that we use to represent this is a percentage. You see, now our percent symbol is going to help us to perform modulo operations. Let me zoom this back. All right. Now for modulo, what you are looking for is a remainder, right? Yes. Now let me print the output 2 and then explain that. So we run. Yes. Now this output is also 1 for modulo, but for a different reason. You know that we can find 4 in 9 just 2 times, right? And after finding that 4 2 times, we have a remainder of 1. There will be a remainder of 1 after we find 4 in 9 2 times. So 9 divided by 4, again, let's go for integer division. Let's do 9 divided by 4. You see, so we can confirm that for our integer division, 4 is making it into 9 just 2 times. And 4 plus 4, that's twice of 4 is 8. Now what's happening to that other one? That's what our modulo is going to fetch for us. See, so we modulo, that's the value we are concerned about, the remainders. And finally, let's talk about exponentiation. Now exponentiation is very simple. So let's say 2 raised to the power 3, right? Yes. And now we are going to print this out. And once we print this, yes, now I'm going to print the output. And we have 8. Yes. So also in programming, this is how we represent an exponent. We use 2 asterisks. And again, be mindful of your white space. If you space them out, it's not going to work. Yes, so those are basic operations in Python. Yes, I didn't print these because I think they are self-explanatory. Yes. So this returns 12. This will give us 3, and this will give us 5. And in fact, this is an exercise to you taking this course. Try to print them out and confirm for yourself, as it will also be good practice. Now, next up, with all that we have learned today, we are eligible to build some projects by TS. So in the next module, in the next section, we are going to be building some projects, some very simple projects to kind of understand the flow of programming and everything. So stay tuned. I promised you some projects. So what you are going to be doing right now is we are going to be building these 3 projects that you see on the screen. First, we are going to be building a nickname generator. It's going to do what the name suggests, specifically what the name suggests. It's going to generate us a nickname based on the code that we write. Secondly, we are going to do a simple interest calculator. So now for this nickname generator, I want us to do just 2 things. I want us to take our first name, and then we are going to combine it. And now we are going to combine this first name with another name of ours, any other name of ours. And then finally, this is going to be our cool nickname. You see? So for example, this is my cool nickname. I know it sucks, but yeah, let's just steady and go. I know it sucks, but yeah. So you get the whole idea. Yes, now I want to show you something. Ideally, this is how you want to program, right? So we know that these are the 2 things that we need to get our nickname generator working. So what do? Python knows nothing about this. You understand? These are just characters. They are text. They are supposed to be strings from the lessons we learned. But let's get rid of those errors first. Yes. Now we have gotten our name into formats that Python can work with. So this one, name, and this. So now we want to do something with this. Now if you run this, nothing is going to happen. We won't get any errors, but we still are not doing anything. So let's create some variables, right? So we say first name equal to, yeah, so we have done an assignment over here. Now, wherever we see first name, it means Daniel, because it's keeping Daniel. And now, what should we call this? Let's say cool name. Yeah, very creative, I know. Again, yes, and we have cool name equal to place, right? Now, what do we want to do? So we want to take our first name, right, add it to our cool name, right? Yes, this is what we want to do. Now, again, this is also going to work, right? We are adding these strings, you understand? So again, we want to store this in a variable, right? So we say equal to, and now we can say nickname like this. Again, watch your white spaces. So we can say our nickname. So we can come here and then we'll say that our nickname is equal to our first name plus our cool name, just like this, right? Yes. So I'm actually going to run this. Yes. Now I want to teach you a cool trick. So instead of just returning our nickname like that straight ahead, we can add some text to it, right? So we want to print out my nickname is like this. Now there is two ways that we can go for this. We can either go for a comma or we can go for a plus. Nickname. All right. So we print my nickname is, and then we add our nickname to it. Now let me show you something very important. Let me show you something very important at this point. So I'm going to run this. Yes. So can we look at the output right here? Now we can see how our Daniel Blaze is appearing, right? Yes. Now we have to fix that. Now there's two things we can do in such a situation. We are going to add a space in front of our first name, and then ideally that should fix that for us. Yes. So we have Daniel Blaze like that. Yes. Now there might be situations where we'll be working with two variables. Okay, just like here, two variables, and we don't want to go back into the variables, or even maybe we can't go back into the variables to edit them. So what we want to do is to add a space character. You see, we can manually add a space, a string of space, if you may. That can be some new type of card or something. Yes. And then we still have the same thing. Now we had a double space over here. So let me prove what I'm saying to you. We run again, and yes, we have that. Yes. So you can either use blank space characters, or you can use spaces in between the quotes to control your output. That's a nickname generator in Python. Now let's build a simple interest calculator. Now, once again, before we build anything, what we want to do is know what we have to use. See, we have to know what we are going to be using to build that particular thing, right? So for simple interest, we need a principal, we need a rate, we need a rate, and we need time. You understand? Yes. Now this is how I want you to be writing your code, right? So this is what we need. So principal, rate, and then time. These are the variables you see. And then finally, we want to be printing out our simple interest like this. Yes, so I don't know if you can see. So yes, this is the formula for simple interest. So for simple interest, it is the principal times the rate times our time divided by 100. That's how we can get our simple interest. So we are going to write out the formula in our bracket. So we say principal times rate times time, and then we take over 100. Now again, this is very mathematical. We need all of our values. So we are doing float division. We need our decimals. We need all the details. I mean, ideally, calculations like this are going to be used in finance. You understand? Yes. So we need all of our inputs. We need all of our information like that so that we don't make mistakes in our financial decisions. So now let's say our principal is 5,000, right? So, and then our rate, and now we also have a rate of 5%. And then for time, let's say we have 3 years. Yes, now we can come over here and then we'll be able to compute our simple interest, you see. So now the only thing we have to do is this whole operation has been evaluated to these variables. Yes, again, we are speaking to the importance of variables, right? So we are just going to come down a notch, and then we are going to print. Again, we are going to use our strings. So we print simple interest, make it like this. Yes, so when we are printing this, we can write simple interest is, now this is a string, and now we can return the actual variable itself. Very simple. Let's get rid of that nonsense. Okay, so this is a structure that you need to have. I'm about to verify that this worked. So now, at this point, if you have been following along very closely, you can just run. Yes, and you can see that our simple interest is 750. Yes. So if we put down 5,000 at the rate of 5%, preferably increment, over 3 years, we are going to get a 750 increase. We are going to get a 750 increase. Yes. So now that's a simple yes. Now a final check. Let's increase our principal to 10,000, and ideally, as the principal increases, our simple interest will also increase because they are directly proportional. Yes, so we can see that our interest will increase very greatly, very substantial if we increase our amount. Yes, so that's a simple interest calculator in Python. Now let's look at the different types of things we can do with strings. First of all, we have indexing. Now indexing simply means assessing characters by their position. Now for our demonstration, I'm going to create a string, let's say Python, and now we are going to keep it in a variable s. Now for indexing, this is how it's going to look like. I'm going to add in a comment over here, and I'm going to start typing 0, 1, 2, 3, 4, 5. Now you can look carefully at how I've aligned all of this, right? You can see that right under the P, we have a 0, right under the Y, we have 1, right under the T, we have 2, right under the H, we have 3, and you get the whole idea. Good. So these numbers are just the positions of our letters up here. So P is position 0, Y is position 1, T is position 2, and you get the pattern. Now, let's say I want to access my P, right? What do I need? I need my position 0, like this. So this position is going to access our P. Now, if we go ahead and just type 0, Python doesn't really know what to do with this 0, right? We need to tell Python that we want position 0 of our whole string Python. So what do we have to do? Now over here we have made an assignment, which simply means wherever we see S is Python. Now I want to tell Python that, oh, I'm talking about S and the position 0 of S. Now again, we need our square brackets. So now when we do this, we have P, right? This is supposed to give us P. Now I want to print this out. So when I print this out, ideally we should just have P. Good. And as you can see, we have returned P. Now I'm going to print something else just for practice. Let's print position 4. I think that should be an O. And you can see we have an O over here. Good. Now imagine we have a very long string like this, right? And then we want to print the last character of this string. Now I'm going to go ahead and manually count over all of these. No, that's not what we are supposed to do. We have a handy trick for us. Simply come over here and then we say -1. Now, when we say this, this is going to give us our last character. Now, let's look at the last character we have over here. That's L. Now, when we do this, we are supposed to return an L. And as you can see over here, we have returned an L. Good. So that's basically indexing in Python. Good. Now we have talked about indexing. Let's speak about slicing. Similar to indexing, slicing follows some similar rules. First of all, when we want to slice something, we need to write it in the square brackets, right? Now, like the way I gave you this map when we wanted to do our indexing, this is what we are supposed to follow when we want to slice. So we have three parameters when we want to slice. Now, slicing itself is getting parts of a string. Now, what do I mean by getting parts of a string? So, by slicing, let's think about a piece of bread, right? So, we may want to slice a small portion. Think of your small portion as only the P, or we want a larger portion that could include both P and Y, or we want even the whole thing and then leave a little piece. So that will be from P to O, and then we leave our N. So that's how you need to picture slicing, taking some pieces of bread. All right. Now we are going to try to do some slicing over here. Now, if you look inside over here, I have a start, I have a stop, and then I have a step. Now our start is just what it sounds like. It's our starting index. So when you're cutting bread, instead of looking at it with your eyes and then saying, okay, I want from this to this, in programming, we actually have indexes to help us to do that. Yes. So let's, for an example, let's put in 0. We want to start at the very start, and then we want to stop at the very end. The very end is going to be position 5. Now, when I put in this, it's not going to do what you think it's supposed to do, right? Yes. Now, this is for indexing. Let's focus on slicing now. So I'm going to run. Good. Now, you think that I said I'm starting over here at 0, and then I'm ending over here at 5. So you're supposed to print the whole of Python. No, that's the catch with our stop value. So for our stop value, it doesn't include the ending index, right? Now, what do I mean by ending index? I just mean whatever index is in our stop will not be included. So now I'm going to include 4. That's O. Now, our O will not be added to the string. We just stop at H because the stopping index is not to be included in whatever we return. Great. I'm going to ignore this step over here, and then we'll do a few more, and then we'll get back to that. All right. Now, what you can really do too is to leave our start empty. You can leave either our start or our stop empty, and then just add a single parameter, right? Now, again, I'm going to say stop at 4. Now, when we leave our start empty, it just means start from the very start, and the very start here is 0, being P. So let's just confirm that. I'm going to run, and then again we have PYTH. It didn't change anything. So if you're starting from the very start, you don't actually have to put your 0 in here. Now, we can also do the opposite. So we can say start from maybe 1. Since when we are starting from the very start, we don't have to actually put anything. So from 1, and then we see move on to the very end. Now we'll see that our Y is 1. So we run, and then we have YTHON because we started from 1 and then we moved on to the very end. Now I'm going to leave both empty too, and then we'll see what that does. Now, as you would imagine, we start from the very start and then we move on to the very end. So that's that. Now, let's put in our other argument, and that's the step. So now we know that we want to start from the very start and then end at the very end. But we want to add in a catch. Now the catch is that we don't just move by 1, 1, 1, 1, 1. Yeah, now step simply means how many steps are we taking. So from 0, we take 1 step to get to 1, another step to get to 2. That's what the step means. So we're just moving by P to Y to T to H to O to N. But when we say something like 2, it means we want to skip by 1. So if we skip this, by the time we are here, it means we have moved 2 steps. That's simply what it means. So we move this, skip this first step, and then we go on the second, skip this first step, and then we go on the second. So you can already imagine what we are going to return. Now I'm going to run this, and then we can see we just returned PTO. PTO. Now that's the value for our step. Yes. Now I remember why I actually wrote this line. So when we wanted to access our last position when we're doing indexing, you will see that we wrote something like this, right? Now this helps us to access our last character. So this just simply means we want to go into our Python string and then we want our end. Now we can use this same principle to reverse our string. Yes, you heard me right. We want to reverse our string. So we start printing from the end. So the start. I hope that makes some sense. Good. So now we just want to change our step value to -1, and that's going to reverse our string. And now you can see we have, I'm not going to try to pronounce this. We have NOHTYP. No, I actually pronounced it. Yeah, bite me. So NOHTYP. So that's slicing in Python. Now we know how to slice. Let's look at some string methods. Now think of string methods as things that we apply to our strings to achieve certain behaviors based on what the particular method does. Now from these two, I can use this to explain. So dot upper is going to take our string and then put it in uppercase, and then dot lower is going to put it in lowercase. Yes, so just think of these methods are going to achieve a particular output when we call them on our strings. All right. Okay, all right. So say we have a string, right? Now let's say we have a string, and that string is Optimus. All right. Now, yeah, I'm not going to say Optimus Prime. Now let's say that string is okay. Actually, let's say Optimus Prime, right? Now let's say we want to take this, right, and then want to convert it into uppercase. Want to display this in uppercase. Now, simply what we want to do with our methods is I want to say dot upper, and then we make our brackets, and that really matches it. Like that's it, and it's going to be in uppercase. Now we are not doing anything with this our string in our method right now. So now the bad practice would be to print all of these. Yes, the bad practice would be to print the whole thing. Yes, yes. Now I can print this whole thing. Now again, I'm just doing this to demonstrate the importance of our variables, right? Now we can see that this worked, but yeah, really what we could have done is we could have just taken this our string, and then we are going to store it into a variable. Let's just say name, because this is somebody's name, and then we can just print name dot. We can just print name dot upper, and this should also work. So you can see we have Optimus Prime again. Now, similarly, let's say I'm going to copy from the terminal and I'm going to replace our string with uppercase text. Now, if I had uppercase text and then I wanted to make it to lowercase, yes, you guessed it right. I guess C dot lower, and then that's going to return Optimus Prime in lowercase. Good, good. Now for dot replace, let's just change our string right to I like Python, because of course we like Python. Let's say for some reason we've had a change of mind, and then we now say we like, let's see what do I write, Java. Let's see, now we want to say we like Java, right? Now the way to go would have been, I mean, there's a very short sentence. We could have just erased this and then replace it with Java, but we have a method that can help us with that. Sorry, we have a method that can help us with that. So what we really do is, now let me store this in a variable. Let's say s was string, right? And I'm going to say s dot replace. Replace. Now our replace takes in two parameters, right? Now let's hover over this. Now x and then y, right? So x is what do you want to replace? Now I want to replace Python with, I want to replace it with Java. I want to replace Python with Java. So let's just print this out now. I'm going to print the whole thing, and I'm going to explain why in a minute. Good. Now you can see that this now says we like Java. Now you might be asking yourself, why didn't I just now come here and then let's say print s if I've done the replacement? Now strings are immutable, right? That simply means that we cannot really change them after we have done our assignment. All right. Now I know that sounds contrary to whatever we are doing over here. I mean, I just replaced it and we even saw the output, but let me print the actual string code again. Now you can see that we have I like Java, the replacement we did, and then I like Python. Now this simply means, so in order for our replace method to work, it created a separate address in memory, right? So now when I say they have a different address in memory, it just means that, so think of your memory like a room. It just means that I like Java is in a different place, and then I like Python is also in a different place. So when we come down here to just say print s, it means we are printing the one in this place and then ignoring the one in this place. I hope I'm making some sense over here. So far so good. So what we are left with is our split and our join for the methods. I mean, there are a lot more, but you can go through the documentation and then you find all of them in that respect. All right. So now let's tackle our splitting. So with splitting, what we really want to do is taking a string. Now this string can be any sentence, and then we are going to put it into a list right here like this. So now let's have an example. Use string. I think that's a keyword. So let's just say s for string, right? And now let's see this as a string, right? But now we have something like this. What we really want to do is, at the end of the day, we know that we are going to be printing, so that's clear. So let's just print s, and we say dot split. So you can see that this is the pattern that I've been following all along. So we just call dot split on our string s over here. Now we are not done. Simply saying the s dot split, we aren't actually done, right? We need to tell Python that you need to split at this point or at this point inside our string. So by default, Python is just going to go wherever it encounters a space, then it will just split, and then also by a comma, right? So so wherever it encounters a space, it's just going to split. Now lists are in comments. You have not gotten there yet, but the separators in lists are like comments, right? So for this, we are expecting something like this, comma, s, comma, comma, and then string, comma, right? Now let's just confirm that. So you go this way, and you can see over here, we have this is a string in that fashion. Now I'm actually thinking of a use case where we would actually, let's start. Okay, let's do a date. So today's date is supposed to be in 2025. Oh, no, we want a date, 2025. Okay, let's say it's January 1st, 2025, like this, right? Now, over here, we need to tell Python that when you are moving through our string, we want you to split from where the dashes are, right? In order to separate our date into the components of year, day, and then month, we need you to split when you see the dash. Now, this takes in a string. I don't know if you read through over here. It's going to take a string. So we just put the dash over here, and then hopefully that works out for us. Good. And now, as you can see, we have been able to separate by 2025, comma, we have 0, 1, and then comma, we have 0, 1 instead of the dashes. So that's kind of what we did here. Yes, that's splitting in Python. Okay, so now for dot join, we are doing the total opposite of our dot split. Now, what we want to do is we want to take our list. So let's see, we have a list, all right, and then it has a year. Let's say 2025, and then let me just use today's date, right? And then it has, let's say, 8. So today's 8. All right, so let's say we have a list like this, right? Let's just call it date. Now it has our year, our month, and then our day. All right. Now when we have something like this, what you want to do is, now nobody really writes a date like this, right? So we can actually better the format. Now with that, we want to use our dot join. All right. So I know I'm going to print in the end. So now we need a string, and then we say dot join, and then we say date. All right. Now this is simply telling Python that we want to join the contents of our date list. Like simply that's the whole gist of it. We want to join the contents of our date list together. All right. Now, how Python is going to need to know from us how we are going to join it. And let's see, okay, we want to join it by dashes so that we have a better format. Now, when I run this, you can see we have been able to return our dates in this format separated by dashes. Now, another thing we could do is we can also return by, let's say, slashes. I run again, and you can see now we have our date in slashes. All right. So that really is it. That's the dot join method in Python. Now let's look at some string formats. So we are going to start with an F string, then we'll look at dot format, and then we'll look at the percent formatting. Very old, see, but we'll still look at it. And then we'll finally look at how to format when you have floats, numbers with decimals, of course. So for this lesson, what we'll be needing is my age and then my name. You at home, you can always use your name and then your age. We are going to be formatting based off this premise, right? So now let's look at our F strings. Now I think we already did this, but let's look at our F string. See, yes. So an F string is exactly what it sounds like. It's an F and then our string. You see? Yes. So in our F string, we can write all the text we want. So hello, my name is. Yes. Now the whole lore of the F string is that we can put variables inside our sentence, inside whatever I want to generate. Yes. So we create our curly brackets, and then we can put in our name variable like this, and then we can say I am, and again we can put in another variable for our age, and then we say yes, old. Very clean, like I said, very clean. Now imagine having to do this with all the plus plus that we did for the first time we tried to print stuff. Yes. So as you can see, very beautiful syntax. We have hello, my name is Daniel, I'm 30 years old. God forbid, but yes. So that is it for our F strings. Now I want to teach you a cool trick, right? So let me edit this a bit, and let me say I will be blah 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 years old in 5 years, right? Now obviously if you are 30 in 5 years time, you can't still be 30. So I'll just come here and say age plus 30 plus 5 plus 5, because our variable is of type int. Yes, so this also carries all the properties of our variable. So you can perform a mathematical operation being addition on this variable. So I run that, and you see I'll be 35 years old in 5 years. Beautiful. Not true though, not true. Now let's look at our dot format method, right? Okay. So you can just go ahead and then start with your string, right? So we say hello. That is very similar to our F string, right? Hello, hello, and then we create the variable point, but we leave it blank. We are going to leave it blank this time. So we can say hello, and then we leave it blank, and then we say you are, and then we leave our variable in the curly braces also blank. Sorry, and we'll say years old. Now what we want to do is, because we can't be, these variables can't have no values, you see, so we have to give them some values. So that's where we use the format method. So we say dot format, and then now inside our dot format, we say name and then age. You see? Yes. So they cover respectively. So our name is for our first braces, and then our age is for the next braces. You see? Yes. So I'm going to run this. Yes, and it says hello Danny, you are 30 years old. Yes. So now that's some way to do it. Yes. So now we have options between student 1 and student 2. I didn't really see how to give the lion age and things. I mean, at a point you have to be serious in life. You see, yes, so we have one student here and then another student here. So with this, you can choose from whoever you want, really. So you see between student 1 and student 2. Now student 2 has gotten a shine. Now it's time for the lion to eat Daniel. We print, yes, hello lion, you're 30 years old. That would be one hell of a lion. Yes, so that's it for the dot format method. So for our percent method, we want to do something like, let me see, hello, hello, but over here we say percent s, right? And then we say full stop. We say you are, oh my god, we say you are, we say percent d. Now that is our string. I think this should be a small s, right? Yes. So now that's our string. And I'm going to move everything inside our brackets like this. Yes. So at this point, after we have our string, now again, these are like variables that we are going to be placing. So you can just see percent, and then again we fill in with the order, name, and then age. Yes. Now when we run, yes, this also works. Yes. So now all these really do the same thing, you see. But probably when you're watching this, you're a beginner, right? I want to give you as much information as possible. I'm going to meet that maniac who writes only like this, like he writes exclusively like this. And yes, I mean offense. Yes, I mean offense literally, because why should you be doing all this? I mean, yes, there can be situations where it will be required, but you see, yes, I mean, at the end of the day, that's why it's good to know this, right? Yes. So now let's look at the last one I want to talk about, and that's when we have floats, right? Yes. So for this, I want to change this my score over here. Let's take our score and let's say 92.4 for blah blah. Yeah. So 92.465 or whatever. Yes. We are very smart. So we say print, right? Yes. Now for this, we are also going to use an F string. So right away, let me say name. Let me see scored. Let me say now we pass in our score variable, right? Yes, we pass in our score variable like this. But what we really want to do is we add a colon and then we say dot to F. You see, in the exam. Yes. Now as usual, before I explain, I want to run. Yes. So what did you see? Now this basically converted our score to 2 decimal places. Yes. Now you can see that we have a 5 over here. So the 1 is going to carry over here, like here, making 92.47. Yes. That's 2 decimal places. So that's basically what this does, right? Yes. So that's string formatting in Python. So before we call it a day on strings, I want us to look at escape characters and then raw strings. All right. Yes. I'm going to teach you just one escape character. You can go through documentation to find the rest. I find that this one is the most useful, right? So let me show you what I mean. So we are going to go ahead and print hello world as usual, right? And then we print this, and then you can see we have our hello world over here. So now maybe you want to print our world on a new line. Yes. Now this is very practical. That's why I also added it. Like there will be situations like surely that you need to put something on a new line. For that we need a backslash and then an N. That's all what we need really. And I'm going to run. And you can see we have our hello and then our world on different lines, on separate lines. And you can see they are misaligned. It's the white spaces. So either I get rid of this one or I could add over here. But I'm going to get rid of this one. And then we run again, and then we can see hello world. Yes. And now what you want to do next is an R string, right? The actual name for them is raw strings. Yes. So now let me show you an example. Let's say we want to access a file path, right? Now that file path, let's say it is, let me see my desktop. So let's see C, all right, my C drive. My C drive. Let's see users. I think that's how this is. Users. Let's say Danny. Okay, yes, desktop steady code.py. Yes, so let's say I want to, whatever, right? Yes. Now you will notice that the moment I type this backslash, we had a problem, right? Now Python doesn't do well with backslashes, right? Yes. And then Windows also defines its paths in backslashes. Yes, but does that mean that we are going to stop? No, that does not stop us. There's a way that we can do this. Yes. Now we simply have to put this as a raw string. Yes, just as the name suggests. So this is raw. That's simply what it means. This is going to be our raw string. And you see, we got rid of all our errors just like that. Yes. So when we are working with our OS, and yes, now when we get to the project section, we'll be building a desktop cleaner, right? Yes, an application that's going to clean our desktop. Now we'll see firsthand how this can be very useful over there. Yes. So for now, that's the end of this session. Yes.
All right. So let's stop for a second. If you made it this far, you've been coding for a while. Pause the video, grab some water, stretch your legs, take a break, and then when you're back, We are going to continue. No, seriously, take a break. Ready? Good. We are about to level up. So far, we've used variables to store single pieces of data. One name, one number. But what happens when you are building a real system with 10,000 user accounts? You can't write 10,000 individual variables. This is where data structures come in. In this model, we are diving into lists, tuples, and sets. Think of these as massive organized storage boxes for your data. We are going to learn how to group information together, extract exactly what we need, and manipulate entire data sets at once. This is how real applications handle information. Let's get to work.
We can look at our list. And the first thing I want us to do is to look at how to create our list. Now, to create a list, we literally just have to create a list. Now, this is the syntax for creating a list in Python. So this is a list, right? Now, I'm leaving it like this because I want you to see it as a rectangle, you see. If you flip it the right way, you can have like a literal list on paper coming vertically, but it's going to be a horizontal list, right? Yes. So let's lose some fruits. I've seen this talk with fruits. Fruits make it a whole lot simple, right? So let's say we have some apple, we have some guava, and then some banana. Everybody likes banana, right? So banana. We'd like to store this in a variable called fruits. Now that's how to create a list in Python. Of course, it's a very simple example, but now that we have created it, let's look at how to modify the list. Now, similar to what we just did in the strings, right? If you have not checked out that one, check it out. So in the strings where we had a word like apple, right? And I was saying that this is position 0, this position 1, this position 2, blah, 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 like that, like what I was saying. Now, in terms of a list, it's a grand form of that. So apple, now the whole of apple becomes 1. So if you want to map, that can be like character A, that will map to this A over here. So A is apple. Now our guava will be just our first P, and our banana can be our second P. Yes, that's how modifying of list is going to work in Python. Now, to actually do that, again, similar to how we access for like a single string, we can just see fruits at position 1. Yes, now I want you to take a moment and predict which item we are accessing. Yes, I knew you were smart enough. Now that's the guava. Because again, Python's in programming, we start indexing as 0, right? Mostly. I'm yet to see a language that doesn't buy here. So this is 0 and this is 1. So apple and guava. So we access the guava like that. Now we want to just set it to cherry, right? Okay. So when we write this, we want to take our fruit and then set it to cherry. Good. So in order to confirm that, we're going to print our fruits. I'm going to print the whole fruit list and then we'll see that in action, right? So let's go. Good. Now you can see, as opposed to our guava, we now have cherry over here. Yes, so now that's how to modify your list in Python. Now again, similar to what we just did for our strings, we have indexing, slicing. For that, I'm going to create a set of numbers. Now these are just going to be multiples of 10. So 10, 20, 30, 40, and 50. Like this. Now, again, want to store this in a variable. Let's call it numbers for simplicity. I mean, they are numbers. So, yes. And let's look first at indexing. Now, again, indexing is actually the way that we got to edit our fruits. At the top, when we said fruit at 1, that's indexing. So we used indexing to set our variable to something new. So if I say indexing as 0, again, try to predict what will happen in your mind. This is supposed to give us a value of 10 because 10 is the first in our numbers list. Okay, so that was pretty simple. Now let me also print. Again, I taught you how to access the last character, right? Now let's try this again. So let's see numbers at -1, I'm going to 1, and that's 50. Yes. So now I need you to get to a point where when you are coding like last character -1, that's negative, like Yes, that's our deal. That's our personal deal. Let's uphold it. Now, look at slicing. Again, just like our strings, but we are thinking in larger terms, right? So when we say numbers, now when we say 1 and we say 4, I hope you remember what that means. It means we are starting from our position 1 to our position 3. Again, the last character is not the last position, is not to be included. You understand? So off the top of my head, this is going to print out 20, 30, and then 40. Because again, this position 0, this position 1, 2, 3, and if 4 is not part, we just need 1, 2, 3. Very simple. And yes, that's why actually. So now we can print this. Yes, now don't worry that it looks like I missed this. Like on a normal day, this is how it should be. You write what you want and then you print it. Yes, so that's 20, 30, and then 40. Now in slicing, we know of the step, right? So stepping. Again, if I say numbers like this, now we need a first value, second value, and then a third value. Yes, now I don't know if you remember, you understand? So if we leave this blank, right, it's just the default behavior. Now this means we should start at the first character, like that's how I'm going to put it, and we should end at still the last character, but we should step by 2. We should step by 2. Yes, now I hope you remember what the step does. So again, let's visualize it over here. If I start here, but I'm moving a step of 2, right? So this will be 10. Now instead of me coming here, this is 1 step, I'll move 2 steps, making 30. So our next thing will be 30, and then I'll move another 2 steps, making 50. I think that's simple enough. We just explained it previously. So, and for confirmation, let me just print before you go and say that I'm lying to you. So let's print this. So print. Good. Yeah, so those are just some ways that we can play around with our list. Now play around, I mean manipulation. I think that's more, yes. So that's how we can manipulate, yes. Now let's look at some list methods. Now for that, I don't really think I need these numbers anymore. I'm going to delete them. We are doing new stuff, right? Good. List methods, right? Now, what do I mean by list methods? Okay, so these are methods just like what we did for strings that can be applied to our list to get them to do something. So we have the dot append. This is a method, right? Yes. Now what this is going to do is going to add something to the end of a list. You understand? Yes. So now let's try to add something to our fruit list. Let's see, pineapple, right? Now when we add our pineapple, now this is the method and it takes in a string, right? But where do we want to add the pineapple to? We just see our fruits list. Let's going to add pineapple to the end of our fruit list over here, right? Now to confirm that, right after we append, let's print our fruits. I'm going to run this, and you can see we have our pineapple over here. Actually, you can see. Now you can see we have our pineapple over here. Let me shrink this again. Good. Now the next thing I want us to look at is the dot insert method. So with insert, whatever we are going to add, we can put it at a very specific index. Do you understand? Yes, that's why we learned about indexing all of that first, you see. So now we could say that we want this, our pineapple, to be at index 1. Like this. So insert as opposed to append takes in just 2 parameters. You understand? Instead of the 1, just the string, it also takes in this. Now let me see if that will actually pop up. Yes, it takes in the index and then a string. You understand? Yes. So now let's do that and let's print our fruits and let's see. Boom. So index 1 is our second position, right? So now we have inserted. Now mind you, we said insert, we didn't say I'm not replace or anything, you understand? So it just entered and then now part of it. So now we have 4 list items. Now that's totally fine. It's so that's a normal behavior here. So we have our apple, our pineapple, our guava, and our banana. Very simple like that. That's to print our fruit. Good. Now the next method I want us to look at is our extend. You understand? Now with extend, it's going to help us to add how do I multiple items. You understand? Yes. Now what do I mean by multiple items? So with extend, we are not taking in just an index or a string and blah, blah. We are taking in multiple strings. You see. So let's add in. Let me see. An elderberry. I think that's a thing, right? Again, I'm not lying. And let's see a fake. Yes. Now hopefully this makes this a list of 5 with these at the end, right? So I'm going to run this. List.extend takes exactly 1 argument, 2 given. Now guys, I'm going to give you a lesson on debugging, right? I don't know if you have the appropriate extensions, but this will be the point where you will Google how does extend work in Python, and you go through the docs. But I think I have a docs plugin over here, so let me see. So right off the bat, you can see that our iterable should be a list containing what? A list of strings. Let me put it that way. Okay, so we have the string part right, but we don't have the list part right. So I'm going to put this in a list right here. So open and then close. Yes. Now I didn't actually go into the documentation because I have the plugin, but watching you should probably do that. Good. And then you can see that it was work like that. So we are able to add these two as a single object, you see, in the list. Now that these are some of the importance of our list too. Now the next thing I want us to look at is .pop. You see, now all these are methods in the documentation. I think there are even more. These are the ones I can find off the top of my head. You understand? Now let's clear this because ideally it also takes in something different. Now for .pop, there's 2 ways we can actually do this, right? We can actually put the value of what we want to remove, or we just leave it empty. Now if you leave it empty, you're just going to take off the last thing. You can see that our banana is RIP right now. Our banana is dead. Mr. Banana is dead because we popped him off, you see. Now let's do something different. .remove. Now this is also another method that I deem important. So let's say remove. Good. So now fruits.remove. Now this one, let me check again. Okay, so it needs some sort of string, right? So let me see. What are we removing? Let's remove Mr. Kwaba, right? Now Mr. Kwaba has been disrespectful to us. Let's just take him out of our list. And boom. Yes, as you can see, we have fired Mr. Kwaba from our company, from our list, from our whatever you want to call it. Good. Now, these are the last things I want to do, right? Yes. So we have membership testing, you see? Yes. Now let's see, membership test. Now, because I've removed Mr. Kwaba, I'm going to use Mr. Kwaba for the membership test. Yes. Now we can just see guava in fruits. Mind you, again, this is like a boolean. This is going to evaluate to true or false, but let's print it. Good. So with this, now let me confirm. Good. Yes, it's going to evaluate to false. Yes, we fired Mr. Kwaba, so you can see that we printed false because he is not in our fruit list. Now that's a membership test. Now let's do a membership test for someone who is actually an employee. So let's check for Apple, right? So is Apple still in our fruit company? Fruit.co.python. True, yes. So you can see that we have a true for that, yes. And then finally, we can look at sorting, yes. And I think I'm done with all of these guys. So let's look at sorting. Yes, now for sorting, it's exactly how it sounds. So for that, let me create. So for that, I'm going to create a list, right? Now, let's say 88, 92, 70. Now these are just some 79. Let me see. 93, 85. Yes. I hope I mix them up well enough. Now these are just some scores we are going to use. And again, we store them in a variable. Let's say scores. Good. Now to use our sorting, we have our sort method. We have a sort method built in Python, right? Now we can call .sort on scores, and this is going to sort everything for us. So now again, this wouldn't give us any outputs. I mean, we have done that, but after sorting our list, let's go ahead and then we'll print it, right? So we print our scores and good. So now you can see that this is in, let me see, ascending order, right? From the lowest to the highest. That's literally what sort. That literally was sort that. So we have been able to sort it like that. Now let me also show you another use case for this, right? Now inside the sort, it takes in a parameter called reverse, right? Now you can say reverse is equal to true if we want the results in the other way around. You see, yes. Now, so maybe you are looking for people to repeat in the class. Now, mind you, you can't repeat someone who has 79. You can't, but you get the whole point. But maybe instead you're looking for smart people, like more smart people. You can just turn around the list and then you actually run. You see the output, and then it's the other way around. We are coming top from 93, then to 92, then to 88, then to 85, and then to 79. Yes. Yes, good. So that's all for lists in Python. See you in the next one.
So at this point on the train, we have to look at our tuples. Now we need to think of tuples as lists that cannot be changed. So with lists, they are mutable, but with tuples, they are immutable. Now, mutable means they can be changed, and immutable means they cannot be changed. So first of all, let's dive straight into it and look at how to create and then use our tuples. Now, the first thing we can do is to actually create a tuple like this. Now, this is an empty tuple. This is also valid for a tuple. You understand? So let's just store it in a variable and then we'll call it empty. This is really the first thing that we can do. And second of all, we can have a tuple like this, and then we can have some numbers inside. So when we have something like 1, 2, 3, this is just a tuple of numbers. So let me come here and then let me say nums equal to, so we've stored it in the variable numbers. And now finally, we can have a single element tuple, right? So let's say I do want to store a number like 25. Now with this 25, what really differentiates it from any number in a bracket that we are going to use to perform multiplication or division or addition? I hope you remember your operations, right? What's going to differentiate it is that we add a trailing comma, and then this tells us that our single variable indeed contains a tuple. Now, whilst I've mentioned that, it's worth it to mention that it's not really about the brackets, you understand? So say I have some colors, right? Yes, this is valid as a tuple. You understand? It's not really about the brackets. This is valid as a tuple. But I would advise that you avoid this altogether. So at the end of the day, your code must be readable. So this is also valid. This is also valid. Very valid to write as a tuple. Yeah. So at the start, you might have heard me compare our tuples to our lists right now. Just like list, tuples support the most of it, but the key thing to keep in mind is it cannot be changed. You cannot change the actual content of the tuple. Yes. So now let's just show some examples. So let me go for the first element in our tuple nums, right? And now I want to print it out. So when I say print, we'll print nums. And now let me do this together. Let's add one. Yes. Now we are about to verify indeed that we don't really need the brackets to have valid syntax. So let's see, colors at the same thing. I'm going to go for 0. Now when I run this, you can see that we have 1 and then we have red. So indeed, when we come here, you can see that 1 is the first element of the tuple. And then when you come here, you can see that red is also the first element of the tuple. Now right below this, let me try one last thing. So I'm going to try to set the first element to something else. So if I say nums are 0 is equal to, let's say, 25, and now we run. Yes, you can see that we have an error, right? So it says tuple objects does not support item assignment. Yes, I know sometimes the error messages can be annoying, but yes, simply means that it cannot be changed. Understand? If you are able to keep these things at the back of your head, it should be what you should be safe. So that's how to create and then use tuples. Good. So right at this moment, we can look at the concept of nested tuples, right? Now, this is the very first time we are going to look at nesting in itself in this course. You understand? So nesting simply means something can have another thing inside of it. Now, I know your minds are dirty, but let's bring it back home. So nesting in the context of tuple, it simply means that tuples can contain other tuples. You understand? Let me zoom in. It simply means that tuples can contain
other tuples, you see. So let's put that in practice. So right away, let's try to create a tuple. Right now, let's give it a name. And you know, I always like using my name in things like this. And then I'll just add another tuple, right? Now, this goes back to our definition that a tuple can have another tuple inside it, thereby being nested. So we're about to nest another tuple in here. Now let's think of some scores. Let's go for an 85, an 88, and then let's see an 89. It's too close, but makes sense, makes sense. That's all good. Now let's think about who would have parameters like this. So we have name, and then we have scores over here. Let's just call it a student. So we can say student is equal to this whole tuple. So the whole bigger thing itself is a tuple, but inside of the bigger tuple, we still have this smaller tuple over here. Good. Now we are going to prove that in a minute. So I'm going to print our students as position 1. Good. Now from all the studies we have been doing, we could testify that this is going to give us this. So this whole thing is position 1. You understand? Yes. So this should ideally just give us the scores in a tuple. So I'm going to print. Good. And then we can see at the very bottom over here that we have the scores over here. That makes the entirety of our position 1 in our student variable. So now let's come down a notch again. And now we are going to try to be printing inside of our second position. Good. So now I'm going to make the first square bracket. Now this is what we want to do. We want to go 1 again to tell us that it is the second position being all of this, right? Now after we have done that, we want to make another square bracket, which means that okay, we are at the second position, but now we want to dig inside of the tuple over there too again, if that makes any sense. Let's see it in practice. So inside of here, let's say I want to return this 88. That's also position 2 of this. So 0 and then 1. Now I'm going to put 1. And then I'm going to run. And then we can see we have 88 over here. So we have been able to return 88 like this. Now let's just confirm. Let me do 0. That's first position over here. So give us 85. I'm going to run. And we have our 85. And then finally again, let's do our 2. I'm going to run, and it gives us 89 like that. Very beautiful, very beautiful. Good. Now let's unpack. Now let's look at unpacking. How do we unpack nested tuples? Let's actually do all of this in one go, right? Good. So to unpack this tuple over here, right, we simply need to look at the parameters. Now this could be anything, but based off the example I'm giving, right, you could see that Daniel is a name. And then out of these scores, we can categorize them by subjects. So now I'm going to open the brackets. Now I'm opening the brackets because we have to follow the structure of this main tuple. We have to follow the structure. Otherwise, the unpacking is not going to work. You understand? So I can say math, English, and science. Those are like the top 3 subjects you have. And then we are going to send it to student. Mind you, student is all of this. Student contains all of this data. So student has in all of this data, right? Good. But let's do some confirmations. So I'm going to print. Good. Now when I print name, I should be having Daniel over here. And you can see I have Daniel. Yes, you can see I have Daniel over here. I'm still returning the other numbers we had first. Let me just comment. Let me comment these out. Let me comment these out. Good. And let's run again. Yes, you can see we have Daniel over here because I'm printing the name. Now let's pick any of these subjects as random. And then let's say science. We run at 89. Now we'll see that 89 is actually the last position of this tuple. And also the last thing we did. So yes, we match them. That's why you have to match them. You understand? Yes. And now you want to unpack because maybe you don't want to do all of these that we're doing over here. This very long procedure we're doing over here. Maybe you don't want to do it. So if you unpack this like this, whatever you want, you don't have to now go position 1 and then position 2. You don't have to do all this when you just unpack. Now, one last confirmation. Let's check our math, and then I'm going to run this. So we have 85. Yes. So that's nested tuples in Python. Okay, so at this point in the course, let's look at our sets. Now, sets in Python are unordered, unindexed, unique, and mutable. Now, what do I mean by all of this? So, unordered in the sense that no item has a specific position, and because they do not have any specific positions, they are unindexed. And unique in the sense that you cannot have duplicates in a set. And finally, mutable, we know what mutable is. We just did tuples. The sets can be changed as opposed to tuples. You can add and remove items from a set. Understand? Yes. So let's just go right into it. Now I'm going to demonstrate an example of uniqueness first, because all of these are based on the uniqueness of a set. Good. So now to create a set, the first thing that we need really is our curly braces. Just like when we did mathematics, when you are doing normal mathematics, this curly braces is what denotes a set. Now let's say we have a set of numbers 1, 2, 3. I know you expected 4, but again for practice, I'm duplicating the 3. And let's see, you want to keep it in a variable, let's see my set, like this. So now let's look at the uniqueness in action. I'm just going to print out my set like this. And now when I run, you can see we have 1, 2, 3, 4 instead of 1, 2, 3, 3, 4. Yes, I hope that makes a lot of sense. So that's the uniqueness of our sets in action. So that's an example of how to create a set. Now, in the same light of creating and working with sets, sometimes we do not want to, or maybe we can't even type it indirectly. You understand? So maybe we would have list and other types of things. We could use the set constructor. So when I have this list A, B, C, right, and I want to turn this list as it is into a set, I'll just use my set constructor. Now let me add in the comments up here. This is what the set constructor look like. So this is your set constructor setting in the brackets. So we are trying to fix this whole thing inside over here where the brackets are. So let me just write sets and let me open the brackets and I'll close the brackets. Now I need to store this in a variable. Let's see, letters. I know already now. Yeah. Letters is equal to sets blah blah blah. Good. I want to print our letters. Yes, the confirmation is going to be that it will be in curly braces, right? Good. So now we have our set over here, BAC. Now, do not be really confused. This does not really matter. Like I said, we do not have any fixed position. They are unordered. So if I actually go and run again, you are going to see a different arrangement and a different arrangement and a different arrangement and a different arrangement here. And because we are coming from tuples where we created empty stuff, let's look at how to create an empty set. Now, you can run into some confusion over here, so pay very close attention. Now, if we wanted to do an empty set, we can't simply do something like this. Let me start with a variable this time. We can't just do this. This is not an empty set. Now let's look at why. So if I print the type, I hope we remember the type of our empty set over here. We are going to see that it's in fact not an empty set. It is telling us that it is a dictionary. So Python interprets this as a dictionary. Now that does not mean that we can't create empty sets. We in fact can by using the constructor again. So we just say set and then we leave it blank. So when we run, now we can see that we have a class of set. So that's about it for creating a set in Python. So now the next thing we have to do with respect to our sets is to look at some operations with our sets, right? So we can add, we can update, we can remove, we can discard, we can pop, and we can clear. Yes, let's look at all of those in detail without wasting much time. Good. Now we need to create what we are going to be adding to. So let's just start working with some numbers. We create our brackets. Let's see, 1, 2, 3. Let's keep it simple when we are starting. It's always good to keep it simple. Now we want to move ahead and then do the add. So this is how it's going to look like. We see nums dot add, and then we open our brackets, and then we can add whatever it is that we want to add. So the first number we want to add is 5. Now after this, I want to print for confirmation. You know how we do it over here. Let's just run. Good. So now we have 1, 2, 3, 5. Okay, let me not confuse us. Either I add a 4 over here or I add a 5. Let's add a 4 over here. Let's run again. Good. We have 1, 2, 3, 4, 5. So that's how to use our add operation. We move on to our update. Now, if you really know something about programming in the whole, you'd know there are a lot of similarities between update and add. But the simple difference is with update, we are adding multiple elements. So let's look at that in action. Sorry. So we see nums.update, and then so this is what we actually need to pull off an update. But with update, it's not just going to take the raw integers. We need to put it in a list. Update takes in a list. So then you just put in the list of whatever you want to add. So we got to 5 over here. Let's add 6, 7, 8. Okay. 6, 7, and 8. Mind you, Python runs from top to down. So this is actually going to happen, and then this will happen. Yeah. Again, let's confirm. We like to confirm over here. Let's print our nums, and then we'll run it. Good. So we have 1, 2, 3, 4, 5, 6, 7, and then 8. Let's get rid of this and let's continue practicing. So next we have to look at remove, and then we'll look at discard. Now if you are seeing a pattern, you're probably right. You'll notice that these are actually in pairs. Add and update, I mean, kind of the same thing with a subtle difference. Remove and discard, kind of the same thing with a subtle difference. You're going to look at soon. And pop and clear, kind of the same thing also with a subtle difference. So now let's go ahead and try to remove something. So we'll say nums. Let's actually make this pretty. Let's give some pretty room. Good. So we say nums.remove. Let's go for 2. Oh, even 3. Right? Doesn't really matter. As long as it's here, it does not matter. Let's just run it. Look at why. So yes, you see we have no errors. That worked. Now let's actually print and see what we have removed. So let's print nums. Good. We have 1, 2, 4. There is no more in 3, right? Good. Now let's do something wonderful over here. Our list originally gets to 8. Now we remove. When you input something that does not exist in the list, you get an error. I'm going to run, and you can see we have an error here. So this is going to throw an error. You understand? That is where we want to use discard. So that's where the second part of our pair comes in, being this discard right over here. So I'm going to change from remove to discard, and you can see we won't have any errors. So I'm going to run. We have 1, 2, 3, 4, 5, 6, 7, 8. And once again, let me just also take out our 3 again, and then we'll run. And we have 1, 2, 4, 5, 6, 7, 8. So it really is about your preference. You have a choice to make on which of the pair to be using mostly, depending on the goal you want to achieve. So now let's look at the last pair, pop and then clear. First of all, let's look at how to pop a random element, right? Yeah, so pop has always been simple to use. We just say nums.pop, and then we are going to pop something like literally. And let's just copy this print over here. They said I shouldn't say print statement. Let's get rid of this and then run. Good. So you can see that our 1 was a sacrificial lamp over here. This is how to pop at random. Yes, let's look at clear. So nums.clear, we are clearing all of the elements. That's what clear does. So pop is just going to pop one thing, either at random or whatever you specify, and then clear is going to get rid of everything. So by the time Python gets to the clear line, it's going to get rid of everything in our nums set. So I'm going to run, and you can see at the end of the day we have an empty set over here. Yeah, so those are the operations we have available to us in Python. I want to split these into two, because next up we are going to be looking at our unions, our intersection, and those kind of stuff. They can be quite challenging, especially if you have not revised in a while. So we are going to split this up. So next up we'll have the next part of operations on set. Welcome back, guys. So like I said, we are going to be splitting the set operations into two parts, and so this is part 2. This is what we are going to be doing today. So we are going to be looking at unions of sets, intersection of sets, and then difference of our sets. So let's look at them in action. Now the first thing I want to do is to create some sets that we'll be using for all of these examples. So for our first set, I'm just going to say 1, let's space them out a bit, 2, 3. Then for our second set, I'm going to say 3, 4, and 5. Good. Now for simplicity, let's call this A, and then let's call this set a B. So we have our set A and then our set B. Good. So now the first thing I want us to look at is our union. Now I'm going to try my best to add in the diagrams doing editing. So union means we are taking the whole of this A, and then we are taking the whole of B, and then making it as a whole, as one complete whole on its own. So right off the bat, I can predict that our full union will give us a result like 1, 2, 3, 4, and then 5. But we need to confirm it as always. So now let me just print our A. I want to print A union B. Now pay very much attention. I want to print A union B. So this is where you have to pay attention. To actually perform the union, you need our separator like this. Yes. Now this character is usually found on top of the backslash, and the backslash itself is close to the Z character. So yeah, if you don't really know your keyboard, so we print A union B. I'm going to run this. Then we have 1, 2, 3, 4, 5, like I said. So union is just bringing everything together. And remember, from the very start, we've been saying sets are unique and all of that. So it's not really going to duplicate these 3 over here. It's just going to overlook it and then have a union for you nicely, like that. Now next, let's look at our intersection over here, our intersection. So our intersection simply means, when we look at these two sets, what are the common elements between these two sets? What do they share in common? So you realize that we have a 3 over here, and then we have a 3 over here. Good. Yes, first let's make our prediction. So if you really understand what I said, you will know that we are going to return a 3. And now I'm just going to print A, and you use an ampersand for the intersection. So A ampersand B. I'm going to run. You can see we have a 3. Oh, sorry. So this is supposed to look like this. Yes, we return a set. So this is supposed to look like this. Yes. So this is A intersection B. This is what A has in common with sets B. Sets A and sets B have 3 in common. Now finally, this last one can be a bit tricky. So difference simply means elements that are in A but are not in B. So kind of how in mathematics sometimes when we want to say subtraction, we say difference. So we want to take out A from B. I don't know if that makes any sense, but let's look at an example. Examples always help block it in. So if we want to find A difference B, now just think of the difference as a minus, you see. So let's think of it as A difference B, like this. Good. Now let me break it down. Let's actually analyze all of this line by line before we run, so that we'll be able to understand it very well. So when we say A difference B, it's simply like A
minus b. So let's even think about it in an actual subtraction sense. When we want our a, we are taking away everything that has to do with b. So first of all of this isn't supposed to count. Now you also realize that this is shared in common with b, so it's part of b. Now again, I'll use the diagrams in editing so you actually notice what I'm talking about. If we had our Venn diagram, this will be in the intersection engulfing b. So this is also shared over here. So basically, any number you find here that you still find in b should not be included in the difference. So again, let me make our prediction. I'm saying this should give us 1 and 2 if I remember my Python very well. So I'm going to run this and you can see we have 1, 2. Yes. So just elements in A that are not in B. Again, if that makes any sense. Good. So now let's do it the other way around, just for understanding. So I'm switching the positions, B and A. And now let's go through this again. So first of all, everything over here is disqualified because we don't want to return it. It's B minus A. We don't want the A. So we've kind of thrown the A away. Good. And again, we'll find that 3 is in common over here. 3 appears in A, but we want elements in B that are not in A. 3 is in A. So again, I'm just going to make the prediction and say we return 4 and then 5. And when I run, you can see that we have truly returned our 4 and then our 5. So I always want the best for us. Let me add one last one. So let's say symmetric difference. So with this one, it's kind of the same thing, but in this case, whereas we will see something like maybe you don't want A or you don't want B, this time we don't want the common elements. So anything that appears across board will just be taken off. You understand? Yes. So let me actually write. So let me just predict again. Anything that cuts across will not be predicted. So we'll have 1, 2, 4, and then 5. That's what we'll be left with. And then to actually do the computing, and then you print A power B. I'm going to call it power. I don't know the actual name, but it's above my key 6. It might be there for you too. So you print this and then let's confirm. You have 1, 2, 4, 5. Yes, so that's symmetric difference. So that will be it for our sets in Python for the purposes of this course. And then next we are going to be looking at our dictionaries and then our functions, and then we'll start building all of these school projects, and then we'll call it a day on the course.
Good. So we've officially hit a bump in the road. This is the exact point in every coding journey where most beginners get overwhelmed and quit. But I need you to lock in because this model is going to be where the magic actually happens. And of course, I hope this does not happen to you because you have me and I've explained this very, very well to the best of my ability. So up until now, our code has been running straight from top to bottom, one line at a time. It's basically just a glorified calculator. But real software has to make decisions. If a user enters the right password, let them in, else we block them. So whilst a game is running, we keep updating the screen. This is called control flow. We are going to cover if-else statements, for loops, and while loops. We are moving away from just storing data, and we are going to teach your code how to actually think and evaluate and react. Now take a deep breath and let's start writing some logic.
So control flow. Now what do I mean by control flow? So you notice that we program from top to down, right? And then so in order for everything to not be chaotic and in order to work effectively with our loops and all that, we need to understand control flow. We need to be able to control how we flow, if that makes any sense here. So we are trying to look at how programs can act differently and how we can influence that different decision based on conditions. Yes, so in life in itself, sometimes we need to make a decision. Do this if that, or do this if, those kind of decisions. So it's just that kind of thing. So let's just look at an example right off the bat. So let's say we are aged 18, right? Now when we are aged 18, we are something, let me just call this age for simplicity. when you are at 18, you are something, right? So if we say so, this is where we are going to add our control flow, right? Now, the first thing what we are doing now is conditional statements. Now we have three conditional statements. Let me put them here. We have if, we have else if, which you should call elif, just to keep it in your mind. And then we have else, like this. Now we are going to look at the if first. So we say if age. So before I complete this particular if statement, right, let's have something very important in mind, and those are our comparison operators. I mean, they should be simple enough, but let's just keep it in mind. So over here, we want to say if age is greater than 18, right? If we want to see something like this, then we can print you are an adult. So from our basic mathematics, you can see that this is our comparison operator. Now this condition is not actually going to work because greater than 18 to start printing from it only applies from 19, but the age is actually 18. Let's see that in action. So nothing happened because the condition is not satisfied. So if age is greater than or equal to 18, and then we run, you can see that in fact we are an adult because 18 is inclusive, greater than or equal to. Now let's look at another combo. So we can say if age is equal to 18. Now straight off, you can see my editor is showing me this zigzags under my equal to, giving me an error. Now this equal to is used for assignments. Typically, I think we've already gone through this. This equal to is used for assignments to store 18 in this variable age. So if we want to write something like this, we are trying to do every assignment and it's not even going to work. So when we want to compare, we just double our equal to and then we'll be fine like that. So this is another comparison operator. Yes, I wanted to be commenting them over here, but I think I'll just leave a screenshot of all the comparison operators in editing and then you'll be able to fend for yourself like that. So I'm going to run, and indeed age is equal to 18, so you're an adult. Yes, so this will be our first example, then we should be good like that. Now before we even go to this, let's look at the last one first, because this is an opportunity to look at it directly before we even bother with our else if. So you realize when we did this, yes, when the condition was not met and we ran, nothing happened, like absolutely nothing happened. So let's reduce age to 17, and then the condition is not met. You are not an adult, you see. So maybe this is a program you are writing for a bar, so that they test all the people that come in and they see that, oh, this is someone who can drink the alcohol or not. Good. So when we write our else statement, and now we say print. Yes. So once I've written something like this, I hope you know where this is going. Yes, we didn't do flowcharts in this course. I think again, maybe diagrams will come in editing. So if age is greater or equal to 17, then they are adults. Otherwise, they are still a minor. Good. So right now, when the condition is not met, yes, you still be a minor. Yes, I hope that makes a lot of sense. If the condition is not met, you still be a minor. So now we have two things. And now let's meet the condition again. Let's bump ourselves back to 18 and then we are adults again. Good. That's very good. We can add in this one. Yes, let's add in this else if, right? Good. Now I wanted to create a whole new example, but let's just keep up with this. Yes, so if I add an else if over here like this, now I need to give a condition, right? Which condition would I give? Let me see. So else if age, let me see, is greater than or equal to 60, right? And then our colon, our paragraph is, we can print, let me see, retire. Let's print retire Orange. Yes. Good. And now let's see it in action. Let's keep this as a 60. Yes. Good. So I've just messed around with the conditions a bit, right? And then because of this new condition I've added, if you are greater than 60, then you should retire. And I've just made this equal to 18, and you get the idea. So when I run this, you can see that we did it to retire already. Yes, so that's just some control flow for you. Yes, when you're writing your loops and all that stuff, there's a way you can just make all of this come together. You understand? Yeah, so that's some basic lesson on control flow in Python. So right before we move on to the dictionaries, let's tackle something very important, and that's our loops. Now, a loop simply means a repetition, right? So if we look at an example of from when we our schooling days, right? You wake up and you do the same thing over and then over and over again. At least when life used to be very simple. So that's an example of a loop, something you do over and over and over and over again. Now let's go over a classic example, and that is printing numbers, right? Now let's look at an interval from maybe 1 to 100, right? Now the traditional way to do this would have been to print 1, and then you are supposed to print 2, print 3, print 4, 3. You can see the headache with this, right? This is not going to get us anywhere. You understand? So that's where our loops are going to be coming in. Our loops are going to help us achieve all of these tasks really easily, right? Good. So now I believe that we have already studied about our lists, and then we practice with fruits. So again, let's just make a replica of our fruit lists. I remember we had an apple, we had some banana, and then I think some guava, and I think some guava, and I think some guava like this. Good. So before we do our for loops, let's assume we want to print everything that we have in our fruit list over here, right? Now usually that would be something like we print fruits at index 1, you know, the indexing we did and all of that. Yeah, so traditionally this is what we are going to do. We are going to do this for index 0, index 1, and then index 2. But let me just go ahead and run 2, and then we'll see that it actually works, but it's not the best way. Good. So this is how it's going to be. So if I add another line and I put 1 and I put 2, we are going to be able to print everything, but that's not really ideal for us. So what will be ideal for us is to use our for loop. Good. Now with our for loop, this is the structure. So we say for something in fruits. Good. So if we study these statements critically, we are saying for something in fruits, right? Good. What do we notice? We notice that this is identical to this because that's where we are looking. We are looking inside of this fruit list. I hope that makes a lot of sense. Let me go over it again. We are looking inside of this fruit list right over here, and then we are saying for something in fruits. Now this character over here can change into whatever you deem fit, right? So we know this is a list of fruits, so we can see for fruits in fruits, and then yeah, you be good like that. I personally think this rather is confusing, but that is the convention, so let's just follow it, right? Now for fruits in fruits, we are just going to print our fruit. I'm going to run, and you can see that we have printed everything over here. So simply what this does is initiated a loop, a condition, right? So for fruits in fruit, so for everything over here, this is it in action, right? We go to an apple, we say okay, this is something, let's print it, and then we printed an apple. And then went to banana, it's still something, it counts, let's print it, and then we printed it. Went to guava, it's still a fruit, so let's print it, and then we printed it. Yes, so that's an example of your for loop in action. A very simple example, but yes, that's an example of your for loop in action. Yes, good. So that's an example with our fruits, right? Now I'll be very naive to not mention this. So we have another way of looping, right? This has to deal more with numbers. So we can say for I in range. Now right off the bat you can see range. So let me hover over this and see if we can have, okay, good. And when we look at this statement compared to this other statement, we find that they have a lot in common. At the same time, they do not have a lot in common. So for fruit, this time we say I. Now usually I is for integer in a range. So we are supposed to specify a range now. So we say 10, right? And you say print I, just like we are printing fruits. So again, this is going to go over, and then we say okay. So I now at default range starts from 0, right? So we go to 0, and then we say okay, let's print that. We go to 1, we say let's print that. We go to 2, we say let's print that. You get what I did, just like we did for this. Now let's go back to my first example where we wanted to print from 1 to 100, and then let's try that straight ahead. So when I run this, you can see we have, when I run this, you can see that we have 99 over here. Yes, so with range, the last term is not inclusive, as you will find with Python. Generally, the last terms are not really inclusive. So if I change this to 101, I'm going to have 100 inclusive. Yes, I'm going to have 100 inclusive. Now let me actually check the first. Good. Yes, like I said, range default from 0. Yeah, so that will be it for loops for the purposes of this lesson. That's a for loop in Python. For loops, and then we have while loops. So the difference I want to leave you with for this is that for the while loops, when we are using it, if we don't know the exact number of times we want to repeat something. So let me see if I can undo. In the previous examples, you could see that we know that we want to print from 1 to 100 over here. So we say for I in this, we know that we want to print all of this. So we say for fruits in fruits, right? Good. That's why we use the for loops. Now, if we do not want to do that, we'll use the while loops. Now, you may not understand, but let's just look at some examples, and then it's going to become that much clearer. Okay, so assuming we want to count from 1 to 10, right? Good, we need a starting point. I'm just using this to demonstrate our while loops. So our starting point is going to be 0, right? Now we need to store this in a variable. So let me call it count. I want to call it start, but let's call it count. So we say count is equal to 0, like this. Now this is where our while loop is going to come into action. Now think to yourself, which condition is going to help us to be able to count till 10? You understand? So we can say while count is less than, let's say, 11, like this. Good. So while count is less than 11. Yes, when we say this, so we mean when we get to 11, we should do nothing. While count is less than 11. When we get to 11, we don't want to do anything. Good. So what we want to do is we want to print. Right, the moment we enter the loop, we want to be printing something. So let's just see a string count, and then you remember the comma method, and then the actual variable is self count, like this. Good. This is what we want to return. Now when we return this, we want to do another thing again. So we want to go and then increment our count. I hope you remember how to increment. This is one of the very first things that we did, right? Yes, so we are done. So let me just print that and let's see it in action. And then I'm going to explain something very dangerous we call an infinite loop. You see, so you can see we have our count 0, our count 1, straight to 10. That's very good. Now let me explain to you an infinite loop. And you always have to try to avoid this kind of loop, when you're programming, right? So if we look at this critically, let's just do a diagnosis like we always do. So we start from 0, our count is 0, it's nothing. And then we went to set a condition. We said while count is less than 11. Now this 0 is static, nothing is happening to it, so it will always be less than 11. Then we went ahead to do some prints over here, all nested under this, right? So when we are doing this print over here, we said we want to print a string count and then the variable itself. So this is what happened. It has happened over here. This is our count and 0. That's what will happen next. Now we say we want to increment our count. So count plus equal to 1. 0 plus 1 is what? 1. So this will now be 1. Now when this is 1, the whole thing has to continue again because 1 is not 11. Yes, at the very beginning of this whole loop session, what do we talk about? We talked about repetition. This 1 is not 11, so the whole thing goes again, and then we'll print 1. And then the whole thing goes again, and then we'll print 2. And then the whole thing goes again, and then we'll print 3 and 4 and 5 and 6 until we get to 11. Now when we get to 11, count is not less than 11, it is equal to 11. So then we can exit this, right? Now I'm going to get rid of this increment line, and then we are going to see our infinite loops in action. Very dreadful. Now if you don't have a very reliable machine, don't actually try this. Just keep it at the back of your head, you see. So I'm going to run this. You can see it just keeps running. I can let it run and it will run all day. So we have 0, 0, 0. It's going to run all day if we don't do anything about it. Yes. So that's just our while loops. Yeah, and a use case for our while loops. Be careful with them. Yeah. So let me actually just terminate this. So that's a good example of our while loops, right? Good. Yeah. So everything I hit here is actually a breakpoint. I don't know, for the purposes of this course, we may not talk about that, but these are lines that will break your whole code. Yeah, so that's the while loop in Python. If you look at my screen, you can see I've written break, continue, and then pass. Now, I'm not making fun of you. I'm not giving any form of instructions. These are control statements that we have in Python whenever we are dealing with our loops, right? So we are going to look at all of them in action. So first of all, let's look at our break. So in similar fashion, let's just create a condition just like I've been doing in the other lessons. In range, let's just choose a range and then say 5. Now at this point, for anyone who has been coding along, this is a very common error that Python developers face. Whenever you want to do a loop, you need a semicolon over here. Look for your semicolon, and then on the next line, it has to look like a paragraph. Those are just some simple things that you have to keep in mind. Good. Now we need to write a condition. Yes, any condition at all. So we say if, let me see, I, let's say is equal to 3, guys. So now we've made another if statement over here. This is an if statement, you understand? Over here. Now this also needs a semicolon, and when we go under it, we also need something like a paragraph. When I have this, right? Now I want to say break. So let's look at this. So semicolon paragraph ish, semicolon paragraph ish, and then you write what you want to write. So we use our keyword break. Now we print our I. Good. So let me actually just run and we'll see what happens, and then my explanation is going to come. So yes, we can see that what we have here is 0, 1, and then 2. Good. So we can see that we just have 0, 1, and then 2 over here. Now that tells us that this break statement is telling us that, so whenever Python sees this break statement, it's telling it to stop whatever it's doing, no matter what, like just stop, you see. if I is equal to 3. So whenever I is equal to 3, get stopped. So first I will be 0 because range defaults from 0. So it's fine. It will print it and then to continue. I will be 1. It's fine. It will print it and then to continue. I will be 2. It's fine. It will print it and to continue. But the moment I is 3, the condition is satisfied. Then we just break, like literally break time, and then we move on. Yes, that's the break for you. Then we can look at continue. So again, let's just create another range. Let's use 5 again. Again, our colon, paragraph ish, and then we write what you want. We say if I is equal to 2. Good. So when we have if I is equal to 2 like this, yes, if I is equal to 2 like this, we need to add another statement, right? But right here, we just want to say we want to continue. Yes, as opposed to the break, we want to continue. And then we come and then we print I over here. Good. So let's run this. Good. Yeah, so you can see what happened as opposed to the break. So what we want to do is we just want to skip. You understand? Like when this condition is met, we just continue. We don't come and print anything. You understand? Otherwise, if this condition is not met, then we print our I. I don't know if that makes any sense. Let me go over it again. If the conditions here are met, we do this. We just continue. And if they are not met, we print I. Good. So you can see that when you got to 2, we didn't print. We just continued. And then went to 3 and then went to 4. Yes. So that is the use case for our continue. And finally, let's look at pass. So pass is very simple. Like it's very simple to use our pass. Let's see for I in range 3 like this. And I literally do not want to do anything. I'll say pass. Let's say I'm not prepared for the logic I'm about to write. And so sometimes you are building these applications. You know the functions and loops that you want, at least at a high level, but you don't really know what you want to do in them. Whether you want to call another function, what you are passing to, what, like you don't really have the details. You can just make pass and then you do the whole structure. And then you make another one. So for I in range, let's say 64. Then we say print I. So maybe we know definitely what we want to do with the second one, but we don't really know what we want to do with this. In the first, loop, right? So what we don't want to do is our whole application must not crash just because of that. This is too long. I just want to make a demonstration. Our whole application must not crash just because of this. You understand? So what we want to do is we just want to hit our run. So you can see that we have no problem with the results. It have been printed over here, but we just ignored everything over here. We just passed. Yes. So those are the control statements that we have available to us when we are looping in Python.
So if you are still here, you survived the loops. You know how to store data and you know how to make your code actually think. Now we are putting it all together for a massive project marathon. But first, we need to cover one last crucial data structure: dictionaries. If you ever want to build a real full stack application, manage user dashboards, or handle a secure authentication flow, you'll be using dictionaries. They are the literal backbone of modern web and software development. Once you nail down how they work, the theory stops. We are going straight back into building 3 back-to-back projects: a login system, a dynamic restaurant menu, and then a contact book, all with dictionaries. So this is the exact moment you transition from just learning things to actually applying what you have learned.
Right off the bat, dictionaries are mutable on ordered collections of what? Items. Now collections here, we should think about what? key value pairs. You understand? Okay, so we should think about key value pairs. Now they are defined using curly braces. So curly braces like this, curly brackets, and consist of key value pairs. Each key is unique and is used to access its corresponding value. Okay, so now I want you to think about situations where we need a key value pair, right? But you can pause the video and think about that. But in order not to waste time, let's just go into mine. So when we have a student like this, right, we can populate the student's dictionary that we are trying to create with some key value pairs. You understand? So we know that every student has a name. Now I want to keep the name as a string. You understand? So let's go ahead and keep the name as Alice, right? And then want to keep our age. So let's say age. And now let's say ages. The person has to be young. Let's say 25, right? And then we need to add their major, or we could call it subject, but let's just say major. And then we'll add another string. And then we'll see computer science. Good. Now I really hope you can notice something very important over here. You can see that we have lines under this. Now this is on purpose, right? Do not forget to be separating each key value pair by a comma. We need to separate each of our key value pairs with a comma in order to have a valid dictionary. All right. Yeah, so that's how to create our dictionary, right? Good. Now these are rules that we should keep in mind when we are using this our dictionary. Okay. Now the keys could be anything immutable. You see. Now any data type that's immutable can be a key. Immutable in the sense that it cannot be changed. We don't want our key to be something that we can change, because if you can see the next comment down here, we are going to be accessing values. So we don't want the thing that we are going to be using to access values to be changed. I don't know if I'm making some sense over here. So we don't want anything here to be able to do what? To be changed. You understand? Good. So the most common data types that we can use for the key are strings and then integers, because they can't be changed. And not unless you are going inside here to change them, they cannot be changed. Because that's what Python used to find our key value pair. They rely on the keys. So we want Python to always be able to find our key. So we make sure our key is an immutable data type. So now let's look at how we can access the values, right? Now, like I said, we access the values using our key, right? So we need to identify the dictionary that we are going to be looking inside. If that makes any sense, we need to identify the dictionary. Then we need to use our square brackets, right? And then we tell the name of the key as it is, bar for bar. So when I see name, they should be able to return me the name of Alice, right? It's supposed to return me the name of Alice. Now, as you know in this course, this does not do anything. It does not give us any output. So let's just add a print over here, and then we are going to be able to return our student's name. Good. So if you look here, you can see that we have Alice. I don't know, this is a bit small. Yeah, you can see that we have been able to successfully return the name being Alice. Okay, good. Now there's something that we need to consider if we are going to be using this method. There's something you're supposed to consider. Whenever we use something that's not here in the keys, we are going to throw an error. Okay, so let me come here and then let me see size. Since size is not a key in our student's dictionary, you can see that we have an error. You see, yes, but fear not, there's a way to work around it. Good. Let me change this back to name so I can work with this. And now let's use our dot get, right? our dot get works the same way as this by using the keys. That's why we always want our keys not to be changed. They must be immutable, right? So we identify our dictionary again. So I'm going to go for students like this. So students, right? And now you know how we call functions. So this is students dot get, and then we put our braces. And now we go and get. Let me see. We have already gotten our name. Let's go for age. Let's go for age like this. And once again, this does nothing. We need output. So we go ahead and then we print. And now when we run, you can see that we have our name successfully and then our age successfully being 25. Yes. So that's how to access values that we have in a dictionary. All right, good. Now what we can do also is to add new key value pairs. We can update our dictionaries with more pairs, with more lines. Let me put it like that. Okay. So in order to do that, what you are going to do is, again, we need to identify the dictionary we are going to be working with, right? And it is stored in our variable students. So we just say, okay, so we want to go to students, and now we want to create our square bracket, right? And now I want to add, let me see, let's add gender, right? We want to add gender. Now we need to set this gender to be equal to something. So we say gender is equal to. Now Alice is a female, so let's just say female. All right, good. Now once again, this does not do anything. So once again, we'll not be able to see this. So at the end of it all, let's print our whole dictionary. Okay, let's print it again. Right? Yes, and then we print students. So let me run this again. Good. Now you can see that we have our name, we have our age, we have our major, we have computer science, and then we have our gender to be female. So we have successfully added something into our students dictionary. You understand? Now we are not just going to leave it at that. Let's also add, let's also change some of the records. So what you can do is you can update again. Well, if let's say you want to change this age, right? When you want to change records, you can also do that. So we go for students, and we can change, let's change the major, right? Maybe the person, she fancies biology. What do we choose first? We chose computer science. Maybe Alice ran away, because let's be serious. CS is very tough. You understand? Yeah, so once I run this again, and you can see that our major has been updated to biology. Yeah, so that's how to be manipulating our dictionary, right? Now, finally, what I want to talk about is how to delete information from our dictionaries. Okay, if you are lost on this, you may want to move back into the previous lessons, right? Good. So once again, we need to identify the dictionary that we want to work on. So we say what students.pop. Okay, nice. Now what do we want to pop, right? We want to pop, let me see, our age. So when we use pop, oh, maybe I should have taught the other one first, but no, let's look at this. Let's look at it. It's fresh in my mind, so let's look at this. So when we want to use this pop, right, and we are saying we want to take away age. Now pop is going to knock the whole thing out for us, but it's also going to keep it, should I say, in some temporary memory. You understand? So whenever I want to delete in our dictionaries and we use pop, ideally we want to store the value. I don't want to say value of value, but we want to store this one. And want to store this value somewhere. Want to keep it for, should I say, future use. You see? So let me see. Let me create another variable. Let me say removed age. It's got to students dot pop, and then we say we pop the what? We pop the age. Now when I'm done, finally let me print removed age. Let me print removed age. Good. Now let me run this, and then you can see that it kept the age. So you can see that we kept the 25. Yes. So when we are using pop, like we will keep the value of whatever key we are deleting. we are going to keep the value somewhere, you understand, for whatever I want to use it for. So that's when we are going to use the pop method to be deleting, right? Now, another way to be removing items is using the del method, and that's a simpler one. I think I should have taught this first. So with this, we start by saying del, and we say student. We need to identify the dictionary we want. So when we say students, and we go, let me see, let's go to major. We have already messed with age. We go to major like this, and then this is going to just remove everything without keeping anything. So should I comment or? And guys, like, if you watch to this point, tell me, will you guys be needing the code? I've not been keeping the code. I've not been keeping the code. And we print. Let me see. Now let's just carry this line to the last after we are done deleting. And then we'll see everything in our students. Good. So let me run. So let's look at the track record. We print Alice, we print 25, and then we print name and then age. Because at the last point we took out the major, right? Yes, so that's dictionaries for you. That's dictionaries for you. Iterate through our dictionaries, okay? Now with iteration, I'm not sure it's the same word bar for bar in English, but let's just think about loops. Okay, so iteration, let's keep in our head loops. Good. So with this, I'm just going to create an employee dictionary. Okay, let's create a dictionary and then let's fill in some values. So to make this fast, let me just fill out the skeleton of our dictionary. Okay, so both all our keys and our values are going to be strings. So let me just do it like this, and I'm going to copy line by line. I don't know, I think I have to give a Visual Studio course. You don't actually have to copy. Let me see, how many records do I want? 1, 2, 3. Let's do 4. Let's do 4. That means you have to get rid of the trailing comma. Okay, so I'm going to come here. I want a name. What's happening? Okay, I want a name, I want an age, and then I want a department, if that makes any sense. And then finally, I want a salary because it's an employee. Okay, so I want a salary. So let's use John for John Doe, of course. And then age, we'll say 32. Department, let's say IT. Okay, so engineering, and then for salary, let's give them 75 grand, okay, or whatever. We don't do that here as software engineers. You have to be very detailed. So let me just put all of the actual values on. Okay, good. So for this, we have various methods that we can go through. Okay, and then we are going to be going through all of these methods. All right. Method 1. Now we remember that dictionaries are key value pairs. So what we can do is we can look through the keys, and at this point you have a guess what the next thing is. You can write it in the comment section. All these extensions are disturbing me, so you can look through the keys, and this is what that's going to look like. Okay, so as usual, when we want to go through any loop, we start with a for. So you say for key in employee like this. Okay, then we are going to print our key. We are going to print our key. Okay, so let's say we want to decorate this. It's good practice. Let's just revise our f strings. Okay, so we say key like this. Let me close it over here, and then since this is a variable, let's put it in our curly brackets, and then good. So we'll have something like this. So let's just go ahead and confirm that this works, and then we'll move on to the next methods. Okay, so here are results. We have name, we have age, we have department, we have salary. Okay, so that's the first way you can iterate through our dictionaries. Okay, yeah, so let me just go ahead and comment all of these out. So as you can imagine, okay, and at this point I think a little revision is good. We said dictionaries are key value pairs. Okay, these are the keys on the left with the semicolons, and these are the values on the right. Okay, so as we've looked through the keys, well, let's look at the values. Okay, I think that makes a lot of sense, right? Yeah, so let's see, look through the values. Okay, and for this we say for value in employee, Is that what we called it? Good. So for valuing an employee, want to print. Again, let's try our f strings. So we see the value s, and then let's see value like this. Okay, and then we run. Good. And then you can see that we have all the values. So the value is name, the value is age, the value is department, the value is salary. Okay, so these are the values that we have to work with. Good. Then we can do so for the key value pairs. We can work with both. So you can work with the keys, you can work with the values, and then you can work with both. Okay, so let's just look at that in a minute. So yeah, so let me just comment this out for anybody who goes through this. Okay, so looking through the key value pairs like this. I think there's supposed to be a hyphen over here. Let's look at the hyphen. So looping through the key value pairs, and that's going to look something like this. So for key, then we say comma, like pay attention so this part does not confuse you. So for key, comma, value in, we say employee. Then we have to add something extra. We say dot items. Okay, so we say dot items because it's a bunch of things. This is how I'll best explain it to you. It's a bunch of things, so it becomes more than one thing. It's now an item. So we say print, and then we say f string, say key, and then value. Okay. Yes. So once we write it like this, we are using the f string because we want to use a separator, and that's the colon. Okay, and these are the actual variables. So this will bring us our keys. Should I say inbuilt variables? Let me not confuse anyone, but yeah. So I'm going to run this, and you can see that we have all the key value pairs. Honestly, I don't see the point of this one, but I guess I still have to show you because once again, let me comment this out, and we'll see the same thing. I can just print employees, and I can just print employees, and that should also work. Okay, so oh come on, print employee like this. So what stops me from doing this? Okay, so I guess this one is going to give you the information in more of a horizontal format, and the other one is going to give you more of a vertical format. Yes, so that's iteration. Yes, okay, so we are going to be doing something new today. So as we have learned about all these dictionary stuff, methods, iterating, blah blah blah, it's only fair that we look at some real world examples, as real as I can make them. Okay, good. So first of all, let's look at a password login system at, should I say, a very high level. Okay, let's just have a picture of how that's going to be. Okay, so typically you're going to have a user, and then you're going to have two fields. This is how I like to create them for speed. So I do this. Sorry, this is supposed to be a column, and then I do this, and then I put my comma, and then I copy, and then I paste. Good. So we have our two records. Okay, so we have username like this. Username typically. Okay, so you have your username, and let's say it's superdan123, and then we're going to have some form of password. Now passwords are never just stored very raw. Yeah, they're usually encrypted, layers of encryption, but for just practice, let's see 1234. Okay, so just picture this in your head. We are storing these in key value pairs. Okay, so then when someone tries to log in, we'll then make a check, and then we'll say something like, so if user.get, it's not always this exact same flow, but bear with me, as real as you can get. Okay, so if user.get, we pass in the password. Okay, when we get a password, then we do our comparison. Like I said, we use the double equals, and then we say if it's equal to the string 1234, then what do? Let's print something for our users. Then we can say user logged in successfully. Okay, so let me just run, and we say user logged in successfully because it's 1234. Yeah, so that's that. No harm, no foul. But as good coders, I like to think we are all good coders over here. Let's handle the other condition. Okay, so if it's not so, what should we do? We should print, let's see. Now this is something you do: username or password incorrect. Okay, we don't want to tell them the exact one. I mean, we are working in the, at least not the back end, but we know what it is over here. Okay, but you don't want to tell, otherwise hackers know that, okay, I've gotten this one right, I just have to work on the other one. So again, logged in successfully. Now let me change something over here. Okay, not the condition, the actual. So when I change this and I run, and you can see we have username or password incorrect. So just one simple example, and then we'll move on to something else. Okay, so I promised us real world stuff, real world examples. So what's more real than a contact book? Okay, so again, let's go high level. Let's picture what we want to build. So ideally, we want to have a database of contacts, and by database I mean we are storing our contacts somewhere. And since we are learning dictionaries, this is going to be a dictionary, and then we'll later write some rules, maybe some checks or something. Okay, we'll retrieve, so I think we'll get. Okay, so let's just look at how that's going to be. So right off the bat, we know that we are going to be working with some contacts. Again, we know we are studying dictionaries. Let's create our dictionary. Okay, and now what do we need? We need the person's name and then their number. So let me just create two sections: name, and then we'll have their number two over here. Sorry, this is supposed to be a column. This happens to me a lot. I'm going to leave it in. So if it happens to you, then you also know what to do. So again, copy, paste, 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 paste. Get rid of the last comma, and then we are going to try to come up with some creative names. Okay, so we have John, caps lock. We have John. Okay, let's see, Philip. Let's see, of course, me, Daniel. And then let's not be one way. Let's add some girls. So let's see, Linda. Okay, let's see, Deborah. Okay, back to guys. Let's see, Newton. So Isaac Newton. And then let's see, Sheldon. Let's see, Sheldon, like this. Okay, now we want to make up some numbers, but I don't know, it doesn't really matter the numbers we are giving them, not even in length or anything. Okay, you know, I may come back to these projects to teach error handling and stuff like that. So we may write checks for the length of the numbers. You know, in certain different states, different countries have different lengths of numbers and things like that. Yeah, we'll do error handling soon. Let's not worry. Right after dictionaries. So this is our contact book, and then we want to retrieve the numbers. Okay, so if you really remember what we did, we can go like contacts.get. Okay, because now it's getting very tricky. I didn't really think this through. So when you want to get, right, by what I've written, we'll have to manually input all the names here one by one. I don't know, that's not very okay. Let's ask for user input. Okay, so we'll ask for input from our user, and then we'll say, please, let me get rid of, what the hell is that? You say, please enter a name for us. That's how we are going to do it. Okay, and then let's put it as a variable. We say name, because mind you, you could easily write all of this in the brackets. Nobody cares, but we want to do it the right way. And then get takes in a second, should I say arguments? We can just see contacts not found. Okay, so what happens when we do not? You see, let's look at how to use our VS Code. Return the value for blah blah blah. Else, so the second thing we are writing is to cover the else. If what we are getting, we don't get it. I mean, that's the best way I can explain it. So contact not found, and then we do this. Okay, now when we do this, we have not done anything. I keep telling us when we want output, we need to print. So we print. Come on, man. So we print, and then we need to close this bracket, and then let's test out our application. Okay, so right off the bat, the person I'm most curious about is Sheldon. Okay, so I just realized something, and let me just slip it in. What if the user just went ahead to write like this, Sheldon? It's not going to be found. Let's just test the positive cases first, okay? So let's see Sheldon, and then you can see Sheldon's number, a very Sheldon number, like a very Sheldon-like number, sorry. But it's really a matter of how we wrote the names over here. Okay, so I'm just going to take time to make, but we don't also write names with small letters, but whatever. You see, these are the things you have to deal with when you're writing code. And probably, I know there may be a better way. If there is, I'll add it in the comment section, of course. But right off the bat, I didn't think through this. I don't think through stuff before recording. Please forgive me. Okay, so this is a very redundant line. I thought maybe this was not registering here. That's why I took it down here. So let's go dot lower, like we did initially. And I'm going to run. Good. And then it asks us keyboard interrupt. And then it asks us for a name. Okay, so we are going to go. Let's type in capital letters or whatever we want. Sheldon. And then we'll have the number. So let's explain what was happening. Okay. So when we had a mix of capital and small letters here. So when we have this, and then strings too are not really mutable. You can't just change one part of the string that the user is inputting. I don't know if it makes sense. When you compare all small letters Sheldon to Sheldon that looks like this, okay, it's not the same thing, so it's not going to be found. Yes, this is programming. This Sheldon is not the same as this Sheldon. So that's why we're running into issues like that. Okay, so just to prove my point one more time, let's also do this in capital letters, all capital letters, and we are still going to find it because we converted it into lowercase to match this already. And then yeah, so that's how to build a contact book with dictionaries in Python. Let's do a restaurant menu. Yes, I just want us to be able to really visualize and understand how the dictionaries work. Okay, so off the top of my head, let me describe what we are building. So think about a menu. Okay, it will have foods and then maybe their prices, and then you're just going to go in and pick what you want, and then you have that. And maybe you want to do some budget checking or something. I don't know. I'm going to try to keep it simple, but maybe we may check if it exceeds a certain price we want to do if we want. You know, future is bright. So let's just go into the application. So right from the bat, let's create our menu. And like I said, it's going to contain the food itself and the price. So like we do it, let's create the two pairs, comma, and then let's see, copy. And then paste. For this, let's just do 3. Okay, this is the very last one. The important thing for us is understanding. So let's oh my god. Right. Whenever you misplace your hands on the keyboard, it's so funny what you can type. Okay. So let's just say prices. You know what? Let's not keep these as strings. Let's keep this as integers. Okay. I'm having some nice ideas. So let's say right is 10. Okay. Let me get rid of these two. We are just going to keep them as integers. And let's see beans, of course, yam, and let's see 8. Okay, what have I done? Yes, I'm going to leave this in. I mean, these are mistakes any human being could make. Okay, or not Sheldon, but so chicken, and let me see chicken. How much does chicken go for? Let's say 20. Okay, then we have our menu like this. So depending on what you want to eat, we can take certain actions. I mean, whatever actions that we want. I've done it again. We have 20. Okay, let me stick to my 20. Sorry guys. Yeah, so depending on whatever we want to eat, then we can go in and do whatever we want. Okay, so let's think. The first thing we can do is we can get the menu. Okay, so this time we don't have a waiter, we have code. So let me see. So menu.get, let's just go menu.get. So say menu.get, and let me see, how do we get everything? Can we just put in the okay, so instead of printing the whole variable, let me see. Okay, I've got it. Let's go for user inputs again. Okay, so let's just see price is what we want to get. So we create a variable and we ask for user inputs, and we say please enter a food. Please choose food from our menu. I think that makes more sense. Okay. And I've been saying we want to format this into lowercase to match. We want to match it with whatever is in our dictionary. Okay, so that we will not get any problems. And then let's come to our actual menu. Say menu.get. We pass in the variable like this. Okay, and then that should be that. But you know what? This is confusing. Let's just say food. Let's make all of this food. Okay, food. Okay, so we are going to get our food. Now you can imagine what this is going to do. Like from what I was saying, you are just going to return. When you choose maybe rice, it's going to return 10. When you choose beans, it's going to give you 8 like the price. So again, let me know. Don't just take my word for it. Let's print this whole thing for output, and then let's. Oh my god. And then let's see. Good. So I'm going to choose a food on the menu. Let's say beans. And then you can see that we have 8. Okay. Yeah, so that's it. We have 8. But yeah, so that was it. That was really much it. And oh, I think I forgot something. The last argument. Let's go through it. Okay. So we say menu.get. Okay, food. And then I told you about the second argument. Once again, let's read it here. So return the value if it's in the dictionary. Otherwise, let's see. Otherwise, you need to set a default that's going to tend to, so that we don't throw any bogus errors. So say food item not found. Okay. Yeah, so with this, we are going to add a print around it. And then we run. And then let me see. I'm going to write a nonsense mail. Okay, let's say pencil. Let's not insult anybody's food. And then we see that we have food item not found. Okay, so that's our restaurant menu, food menu, whatever you want to call it, with our dictionaries in Python. Okay, welcome back, guys. We are making good progress. So today let's look at exception handling. Okay, so I'll define this video today that we are going to do as how to handle our errors. Okay, but to be more specific about the type of errors that we are handling exceptions. Okay, so now an exception is an event that stops our code from running or executing. So we just think of things that will happen in the flow of our program. We learned of control flow. So we are thinking about things that will happen that's going to stop our program from executing. Now, a couple of things to look at. We have zero division errors, and then finally we have type errors. Now, as time goes on, we are going to know what all these errors are, but let's just start with an example for the zero division errors. Okay, so let me see. When we want to do division, okay, we know in our normal mathematics, we do not divide by 0. Okay, numbers are not really divisible by 0. That's an undefined set. So imagine that we have gone ahead to do that in our code. Okay, now at any point in time, if you are writing a program and we have this line in there, we are going to have an error. And then you can see that this is the zero division error. That's division by 0. Okay, good. What we want to do is, when we have errors in our program, we know this. Our users do not know this, that is going to cause an error. They possibly do not know this is possible. Okay, we want to make it so that it's not necessarily that our application is going to stop running. We want to make checks to handle all of these occurrences so that our program does not stop running. The way we are going to be handling all of these errors, these exceptions, we are going to be using try except blocks. Okay, now how I can simply explain this is, try is for the code that might fail, what we are predicting is going to fail. Okay, and then for except, okay, if it does fail, what should we do? Again, we are going to see all of this are parent. So now let's say I want input from a user. Okay, let's say that I want input from a user, and I want the user to enter a number. Good. So let's say enter a number. Let's be very fast, like this. All right. And now I want to take the number and do something with it. So I want to print, and let's see, for some reason I want to print 10 over whatever number our user is going to input for us. Okay, now as we can imagine, a lot can go wrong over here. Okay, now as we are accusing the user of always giving us errors, let's make sure our input is an integer so that we can work with it. Okay, good. First, let's just simulate the errors before we even do anything. Let's just simulate the errors. Okay, so enter a number. I'm going to go for the one that's going to crash us, 0, and we have the 0 division error. Now I want to run it again, and I'm going to enter jack, whatever that's supposed to be, and you can see that we have a value error. So we input the wrong value. Okay, we input the wrong value, and we also try to divide by 0. Okay, so these are the two exceptions that we have seen so far. Okay, now let's try to handle it. You don't want our program to be stopping. Okay, so we say we try. I said we put this in try except blocks. Okay, now with Python, remember from our first lesson, I taught us about white spaces and indentation. We need to indent this. Yeah, so in Python, wherever you see this colon, okay, for, while, things like that, is usually followed by an indentation. Okay, so now we have a try. We are going to try this code that might fail. Then we say except. Okay, when the user does this, except it's a 0 division error. This is good. Except it's a 0 division error. Again, we put a colon. Again, we indent. I hope we are following. All right. Now we need to tell the program what to do instead of crashing. Okay, instead of just going ahead to crash, we need to do something else. So we say, so over here we are choosing to give the user a message. You cannot divide by 0. Who was your math teacher? Who was your math teacher? And you can see what we have over here. So that's our first exception. Now, if you do remember the second one, I think that was the value error. Okay, so except value error, because we know we always want numbers. Now we need to tell the user something. Again, invalid input. Please enter an actual number. Okay, this should work for our expected errors. Okay, now I'm going to do this again. I'm going to try to do all the nonsense I did initially with the numbers. I'm going to try to input a 0 again, and you see it tells us that you cannot divide by 0 instead of just throwing a nasty error. Okay, so that's good. And again, let me input Paulina. And then you can see that it's an invalid input. Please enter an actual number. So that's about that, but there's something else that we can do. Okay, now we can bundle all of these up. Okay, and then we are going to send a single message for both of them. Okay, so I mean, I wouldn't advise that. It's not the greatest. It's not what you should do first, but as always, the thing that you have to do is not always the easiest to do. Because imagine working with bigger applications, and sometimes even you don't want to be putting what's going on inside of your server out there really, because of like hackers and things like that. So it really depends, but I have to show you. I need to make sure you know of it. So let's just go through it. So except 0 division error. Okay, and now we can put a comma, and then we put value error. Okay, and this is why we generally do not recommend this. At this point, what we are going to print needs to cover both, and then we are just going to tell you something generic like something went wrong. I know you have seen this before, and let me see, close brackets in the colon to make the sad face. We are just going to tell you something like this. Okay, so this is how this is done. Whenever you see something went wrong, it's the developer bundled up, should I see, most of the possible errors, and then just send one generic message for them. I mean, it's simple. So let's try this out. Let's just try this out, and let me input goat, and something went wrong. Let me input the 02. Something went wrong. Like, there are no pointers for the user to really look at the error log, the error message, and then fix their error. So yeah, that's why once again I do not recommend this. So once again, we can play with the formatting and then the order of this. Okay, should I say the flow of this to also get another output? All right, and that's going to look something like this. We do not explicitly get our output in the try block. We use an else block to just get our input. Okay, so let's see, except something went wrong, blah blah blah, and now we come and we see else. So we want to go through all the exceptions first, and then if finally nothing happens, then we print you entered now. Okay, you entered, and then we just show the user the number that they input. Okay, so with this you can use string formatting. I mean, there are a lot of options available to you, but just know that you can have the try, okay, you can have except, and you can also have else. Now, something very important, I think, will not make the tutorial complete, is to add a finally block, and let's look at what that does. Okay, so with our finally block, okay, when we look through this, we do see that, okay, our try block is going to run, okay, and we only throw this error if something happens. If it's a wrong input, we only throw all of these errors if the inputs are wrong. Okay, but with our finally block, it's always going to run. Okay, so let's see, like, we are just saying that no matter what, we need to print this. Okay, so our final block is like we need to print this no matter what. This particular block of code is always going to run, and let me just show you in action. Okay, so we run, and then it's going to ask us for a number. Let's go for the errors. I mean, let's put a 0, and it says you enter 0. Congratulations. Okay, so there was no error. There was no 0 division error. There was no value error 2. And then you might think that's why it still runs. Now let's also look at a case where we do the wrong thing. Let me go for goat. You see, something went wrong, but we still print out congratulations. So the finally block of code is going to run like no matter what. That's just what we should keep in mind. Okay, so this is exception handling in Python. It's not everything, but this is mostly what you should be concerning yourself with, and I'll see you in the next lesson when we do functions. So let's quickly look at functions in Python, and according to me, after this we should be able to mess around with a few projects. So a function refers to a chunk of reusable code. Okay, so reusable, I want us to think about repetition. When you want to repeat something, ideally you want to use a function. Also, I like to keep in mind that functions are used to perform a specific task. Okay, so whatever I want to reuse, ideally is a specific thing that we want to do. Okay, so let's just look at functions. Now, in order to write functions in Python and even in other languages, we have designated keywords that we use. Okay, and in order to write functions in Python, the keyword we are going to use is called def, or we say we define a function. So let's just start. Let's keep it simple. So you say define, and I want to take us back to our very first lesson. Let me define a function called hello world, and I add a bracket, and then I add my colon. Okay, so typically this is how it's going to go. Now if we analyze this line further, we can see that I have this dash over here. Okay, that's because if I write this, it's not valid, so this is just naming syntax. I believe I've already spoken about this, but let's just keep it at the back of our heads. Okay, we do not type spaces themselves when we are doing this. Okay, now again back to the first couple of lessons, we did speak about indentation. So when we do this to define the function, whatever we write over here, okay, coming down from here like this, belongs to the function. The stuff that the function has to execute. Okay, yeah. What we want this function to do, we want this function to print hello world. Okay, good. So again, I want to show us something, so I'm just going to run this. Okay, now when I go ahead to run this, we are going to see that we don't necessarily have any errors, but nothing happened. We didn't receive any output. Okay, and throughout this course I've been saying that when we get outputs we do a print. When we write it we won't get anything, but when we do the print to get the output we get blah blah. I know that's what I've been saying, but with functions we do something very unique and very different. Okay, and let me just try to show us that. Yeah, so after we define our functions, we need to do something that's a call. Okay, we need to do a function call, and that's simply to tell the function to execute. Okay, so imagine you are someone's boss, and then they have a task to do for you, but they need you to give them the go ahead. They need to confirm. They are not that type level of employee yet to do it without your permission, so you have to call them. So just call it a literal call. So let's call our hello world function to come into action. And the way we do that is we use a parenthesis. Okay, the brackets. Let me not see here. Yeah, so we say hello world, and then we just add the brackets. Okay, you see they even kind of look like telephones left and right. I'm going to run this, and then you can see now we have our output as hello world. So that's how to define the functions and how to call them. Okay, and let's go ahead to look at some more interesting stuff. So I've gone ahead to comment these out because we want to look at something different. Now this is a very simple function. Let's try to expand. Okay, now functions can also have what we call parameters and then arguments. Okay, good. Now we are going to look at that in a moment. Okay, so say I want a function. Now let's even just use this as an opportunity to understand when we use functions. Okay, so when we want to reuse something, I want to perform a specific task. Okay, so assuming we are actually computers and we want to greet other people, and then we say okay, define greet user or even users of our application like this, and then we add our colon. Okay, good. Now you realize that different users have different usernames and stuff like that. I mean, you could in theory just use multiple print statements, but that's what you are trying to avoid. Okay, it's a reusable thing. So anytime I have to repeat something, you probably think that, oh, I can use a function. Okay, good. Now since all of our users are going to be very different people, we add something we call a parameter, and that parameter is username. But really, just think about it as a variable. Okay, I know that those guys are coming to come after me. Some people just watch things to find errors and stuff like that, but maybe not technically correct, but just think about it as a variable. Okay, and then want to print something, and I want to print. So let's go back to again old lessons, and we use our f string, and we'll see why soon. So we'll say something like maybe welcome to our app. That's long. Let's say welcome back. Okay, and let's say username like this. Okay, good. Username, and that's why I said we should think of it like a variable, because at the end of the day we'll be wanting our actual username. Good. Now when we want to call this function, This is the distinction between the parameter and then the arguments. So you define the function with the parameters, and then again I said this will not do anything. We need to call our function to come into action. So we say greet user, and then we call our function. But we are not done. This function has a parameter, so we need to call the function with an argument, okay, that satisfies the parameter. Okay, so can again now think of it like we want to fill the variable with input. Let me just see it like that. So let me see which username are we using. Let's see Esther, like this, and we want to greet our user Esther. Okay, and you see we have welcome back Esther. So instead of writing multiple print statements, and then imagine we have, instead of writing multiple print statements, imagine we have another user and his name is Kali, another user, her name is, I don't know, Megan, and another user, her name is, any type of users. Let's go for guys, Greg, like whatever we have. Okay, instead of writing multiple print statements, you can just be using these functions and you make all of these calls. So you can see we'll have all of them over here. Kali, Megan, Greg, Esther. It sounds like a stubborn clique of people. So that's our parameters and then our arguments. Let me cap this for one last time. Okay. We define our functions with our parameters and then we call them with our arguments. So now we've seen the parameters and the arguments. Let's talk about something that's also very important, and that's the return keyword. Okay, so we use this when we don't want the output right away. Okay, I think that's a better wording. So when we don't want the output right away, we use our return. And the way you want to think about this is, okay, it's going to keep this at a particular memory address, and you can just later fetch it when you want. Okay. So far we have been doing functions where we just bring the output right away. Let's try to do something very different. So again, we want to define the function. We say def, and we say multiply because we want to do some multiplication. Now we make the brackets and put our column, and we indent. Now we write everything we want. So what we want this particular function to do is to return, again, keyword return. Now before I do this, I need to make the parameters. Okay, so I say a and then b like this, and now we return a times b. Mind you, we didn't print it, we didn't do anything to it. It's just we returned it, we need the value. Okay, good. So once we have this simple function, I'm going to go ahead to call it just to show us what I'm talking about. Okay, multiply, and now we need to satisfy the parameters with arguments. So let me see. Let's use 2 and 3. That should give us 6. Okay, good. And now run. And then you see that we'll go back to having no output because nowhere in either the function or in the call did we specify that we want output. But make no mistake, the value is still somewhere in memory, and we are going to prove it. Okay, so what I can do is I want to store this in a variable called result. I can just try to print the whole thing back to that. Yeah, so let's just store this. Okay, besides I want to also make the outputs. I want to make it pretty. So now we print our results like this. Now this alone should work. Okay, but I want to use an F string. I want to add something to the message. It's good practice for us. So we see the results. Let's see products. Okay, products is, and now we see results. What is it? Results like this. Okay, good. And now you're going to see that we have output because we have gone ahead to print the product. Okay, so again, we use return when we don't want to print the results right away. Good. Now the parameters themselves don't have to be just one parameter. Okay, we can have multiple parameters. Okay, and let's just look at that. So again, we want to define a function. Let's just go DEF to duped. DEF, that's the keyword, okay. And then let me say introduce. Let's call it introduce. And now which parameters do we need for introduction? Name, age, we can go school, we can go occupation, we can go on and on and on, but let's just keep this simple because we are trying to learn a concept, we need it to stick. Okay, now we want to print, so this time we are not returning, we are going straight for the output. Okay, and I mean that's a pattern. Usually you return when you want to do mathematics, when it's more of numbers. Okay, so name is, or should it be my name? Okay, let's do name as name, and age is age. Good. So you can have multiple parameters, and now let's try to call this function. So we say introduce like this, and we add a bracket, and now we need to satisfy the parameters with our arguments. So for name we put Daniel, and then for age, let's say I'm 50. Okay, and now we are going to run this, and then you can see, guys, we did not put this as an F string, so that didn't work. Now let's try again. Okay, good. So name is that. I'm going to leave this. So if it happens to you, it's normal. So name is Daniel and age is 50. Okay, so that's just showing us that you can have multiple parameters. And before we jump into what I want to talk about next, I want to show us something. Okay, so what if I'm a stubborn user and I put 50 here and I put the Daniel radar over here? Okay, and then I run. You can see that it says name is 50 and age is Daniel. Okay, that can happen because when we are doing things like this, it means we need to match the order. The order is very important. Okay, and I think that's part of why the creators of Python decided to call this arguments, because I mean it's arguable whose name is 50, well 50 cents, but you get the idea. Yes. So I'm going to teach us how we combat this. When we don't want this to happen, we use something we call keyword arguments. Okay, keyword arguments. So when we are doing this, I know this is the age, right? I'm going to say age equal to 50, and now I say name equal to Daniel. I'm specifying what I actually want to print out, okay, regardless of how I've placed it. And you can see we now have the correct thing. It says name is Daniel and then age is 50. Okay, good. So when you don't want things like this to happen, I mean, whichever one you want to use is totally fine, depending on your use case, depending on how you feel, depending on, yes, it's fine. But once again, I have to kind of show you that it exists. Okay, so whichever one you want to use is fine. There is no problem, but just be keeping everything in mind that the order matters. And if you don't want problems with order, you can just be using keyword arguments. Okay, good. Now let's look at default parameters. Okay, default parameters. Good. So in light of this is the same problem as this. I mean, not exactly the same, but in the same borders. Okay, let's say we have a function, and that function is send notification. Okay, good. Now with this function, what we want it to be doing is we want it to send a message to a user. Now once again, the order really matters. I just want to go user message. You can go message user, but yeah. And what I want this to do is to print. Let me use the F string. We don't want to encounter our same errors. And we say user, and then let's add in a colon, and let's say message. I think This should work. Good. Now let's try to call the function. Okay, let's try to call the function. And let's see, send notification. Then we add our brackets. And now you can see we have two parameters. So we are expecting two arguments. Good. Now I come here and then I write, let's see, just one argument. Daniel for the user. Okay, let's look at what's going to happen to us. We get an error. Okay, so it's going to tell you that it's missing one required positional argument. Okay, it's missing one argument. And now what if I'm a user without any messages or any stuff like that? What if our users are not going to be putting in the parameters, or probably we are reading someone's email, we have made an automation setup or something, we are reading the emails, and what if there are actually no messages, but we still have to do the update? I mean, be creative with the scenarios, but just to understand more. Okay, what we can do is over here we are going to add a default. So just like the keyword arguments, this one's for the parameters. So it's a default param or parameter. Now we are going to say you have a new alert. Okay, good. You have a new alert. So this time when I run this, it's going to tell Daniel that he has a new alert. Okay, good. Or we can also call, let me copy this. We can also call with the extra argument and everything is going to be fine. So we can add the message ourselves. See, your download is complete. Maybe we have completed something download. When we run this, you see your download is complete. So this only runs if we add the second argument, and if we don't add it, it's going to fall back to our default argument we added when we defined the functions. Okay, so those are default parameters in Python. Good. So let's look at local versus global variables. Okay, now since the start of this course, I've only spoken about variables in one context. Okay, but we also have other contexts that we have to look at. So we can have variables in a global sense, and since functions have come into the picture, and I've been explaining that when you have a function like this, everything in the indentation belongs to the function. So it's like its own community on its own. Okay, but let me just do some demonstration and we use it to explain it better. That's local versus global variables. Okay, good. So again, we try to define a function with a keyword. I want to say update score. Okay, now inside here we want to say score equal to 50. Okay, mind you, practically the same thing word for word, and you can see that our IDE is even showing us that it's the same thing, but they're in different colors. Okay, so this is going to be the local variable. I want to print score inside function is score, like this. Let's make this an F string. Okay, good. So score inside function is score. So like I was saying, this one is local. Okay, let's imagine this is the bigger country. Okay, so this is the president's score. This score is for the president, and maybe this score is for the senator, it's for the MP, it's for his subordinates, one of the subordinates. Okay, let's just think of it like that. And now if we go ahead to call this update score function, what do you think is going to happen? It's going to give us the score from the subordinates because it's a local variable. The function deals with things in its locality, things within the indentation. So I just want us to see that the score inside function is 50. It looks like I have typos. Function. So you see score inside our function is 50, and that's correct. And now let's just print score. We are going to see the global variable because we are outside of our function. Good. So when we print score, just for printing score sake, is 100. But in context of the function, again, the subordinates, the MP, the senator, and then what he has access to is going to give us 50. Okay, so that's global versus local variables. I mean, there's more to it. We can really go deeper, but I'm going to leave it at this. Okay, good. So this is the last thing we are going to be doing with respect to functions, and then we are going to go ahead to mess with a lot of projects and basically have fun. But I would like to see this can be a head bender. So calm down. I'm going to try to keep the examples as simple as I can. Okay, so functions, as you see them, can call other functions. Okay, and how is that going to look like? Good. So let's say we work for the IRS. Okay, and then we want to do some taxing. So we have a function. It's even fun. Calculate tax. Okay, now with this function, what I want you to do is I want to take an amount. Okay, parameter as amount. I want to return amount times. Let me see, tax. Okay, I'm a good guy. Let's just say 10%. Okay, I'm not God, but 10%. So this will be for me, okay, at the IRS. Okay, and let's see, the person paying the tax wants to calculate their final price. Okay, let's see what they have to pay. All right, final price like this. That's also going to take in amount. Okay, and then we need our colon. Good. Now let's pay attention over here. Okay, now in order for the person to know what money they have left, let's say after paying tax, blah blah blah, they need the amount. Okay, they need the amount. Them paying the tax, they need the amount, and then want to subtract the tax. Okay, so we could have gone ahead to do the computation all in one function, but remember I said functions do very specific things. I mean, they can get specific as this, as having small functions doing small different things. Okay, but we want to take out the tax, which we already have a function that's calculating that. So what you simply can do is you can call the function. So you can say minus calculate. You have to spell calculate tax like this, and then we also see amount. So the moment we do have this, it's going to compute the 10%. Okay, so we have seen that we have called a function, okay, inside of another function, if that makes any sense. And what we should expect is, so this is 10%, right? Let's say our principal amount is 100. That's our final price we'll have after paying tax will be like 90. Okay, so let's see, how do I let's print. Okay, because we definitely need outputs. Now let's just call our final price. Okay, we could have put it in a variable and all that pretty stuff, but let's just call it straight ahead and print the output itself. And let's call it 100. Okay, so I'm going to run this, and then like I said, you have 90. Okay, so I don't know, you can build this program and be using it, give it some form of UI or something, and also have a way to be getting user input itself and be calculating your tax and stuff like that. And hopefully to the applications already do this, so there should not really be a problem. Let's see if you end, let's see if you end 1 million. 1, 2, 3, 4, 5, 6. Yeah, good. So that's our tax application. So this is a very simple demonstration. I mean, it can get really complex, but again, let's keep it simple for understanding. And that will be all for functions in Python.
Welcome to the final stretch. You now have every fundamental piece of the Python puzzle: variables, loops, logic, data structures, and functions. Now we put it to the test. So we are going to build two classic capstone projects from scratch: a number guessing game and then a rock paper scissors game. So these are going to force you to combine everything you've learned so far into robust, unbreakable code. Finish your coffee, crack your knuckles, and let's write these final terminal scripts.
Okay, so for our number guessing game, okay, we want to have a certain range. Okay, and let me be writing this down. We'll have a range of numbers. Okay, and this is the actual range that we are going to be using. So let's say we have a range that's from 1 to 100. So we have two users play against each other. Okay, let's say player 1 and player 2, and then one is going to choose a number, the other is going to try to guess the number, hence the number guessing game. So let me just give us a quick example. Okay, so say I pick 50. Okay, when I pick 50, now the person who guesses, after they guess, let's say they guess 80, my responsibility is to tell them that, oh, the number I picked is lower. Okay, if they picked 40, I now have to tell them that the number I picked is higher, and you get the whole idea. And that just helps them to be able to narrow down and then be able to get to the number. Okay, so for this, what we want to really be doing is we will kind of be playing against the computer. Okay, and what do I mean by the computer? So you want to be just selecting the numbers at random. I mean, to make the thing a bit fun. It's just us over here. We don't have any people close to us or anything. Okay, so what we want to do is we want to pick a random number. Now, to do this, we are going to be using the random import. Okay, so we say import random. So this is just going to help us be able to do things as random. Okay, like literally. Good. So let's create a variable and let's say number to guess, like this. Okay, and now let's tell it what to do. So we want to guess between 1 and 100, like I just said. Okay, good. Now this does not do anything really. We want to be able to perform random operations on this. So we just come here and then we say random, let's say dot, and again we go rand, yes, rand int for random integers. Okay, and just for practice, let me try to print our number to guess, like this. Let's try to print our number to guess. Okay, so I'm going to run this and then we are going to see our number to guess. And what I really want to show is every time it's going to change whatever it has picked. So that's the whole essence of the game. You can see the numbers keep changing over here from 33 to 24. It just keeps changing. Okay, yes, that's the point. And then we will now have to later guess this number. Okay, so let's get back to it. Now I want you to play against this random behavior. Okay, so we want some form of user to be able to play against this random. And for this, I'm just going to straight away, let's call it guess. Okay, since we call this number to guess, let's not call this user, let's call this guess, to maintain some form of consistency. Okay, be keeping note of these things. Okay, you want to be consistent in your variable. So we say guess is equal to, now want input from our user, and then we now need to tell them what to do. Okay, so we say enter your number guess, and this is something you want to be doing. Don't just say guess, specify number guess. Sometimes users can be weird. Okay, so specify number guess. Okay, now as I'm looking at this, we can see that we are working with integers. So what I want to do is I want to cast the input the user is going to be giving me as an integer, so that we'll be able to perform mathematical operations on the number they give us, include us. And these mathematical operations include greater than, less than. You see all the comparisons we want to do. You cannot compare strings in that sense. You see, let's avoid any errors right off the bat. Yes. And now we have these two. What we really want to do is we want to write out the comparison logic. Okay, we want to just come out and then compare this, and then we'll give our conditions. Yeah, so the comparison logic, again, let's brush through it. If it's equal, okay, if you get the actual number, then you get it correct. Okay, and if it's lower, then it has to tell you that you are lower, and if you're higher, it has to tell you that you are higher. That's basically it. Okay, so let's just write this out. So let me see, you say if guess, let's handle the correctness first. Okay, if guess is equal to, and remember to compare in Python we use the double equals. It's a number to guess. The ID should be given this very fast. If guess is equal to number of guess, okay, then I want to print like this. Then I want to print correct. Okay, that means they got it right. Otherwise, that's our elif. Okay, if guess, and you can pause the video and try to think about the logic yourself to see if you'll be able to get it. Okay, so number to guess. So otherwise, if the guess is less than the number we have picked, I'm getting a bit confused. Okay, so if it's less, we want them to go higher, right? So let's print something like, should I say go higher, or let's just make it simple. Let's say too low. Okay, good. And then we say else, because this is the last one. Say else, we print too high, so they have to go lower. Okay, good. And then this is basically it. Okay, now I want us to test out our application, so I'm going to go back to print the guess so that we can just debug our logic. Okay, let's print number to guess. Okay, so when we print this number to guess over here, we get to see the random guess. It's supposed to be random, but we get to see it, and then we use it to run our tests. Good. So I've run this and we can see something very interesting. What I want to do is I want to test our first condition, the correct one, and we can see that the number is 20. So we just want to match it. So it's 20. And then you can see that we have our correct. Okay. Now I'm going to run again. We see it's 11. Let's try to predict 2. And it tells us that we are too low, so we have to go too high. Good. Else, let's try again, and let's try to go too high. Let me literally go 99. And it's telling us that we are too high, so we have to come low. Okay, good. So this means that our base logic works. Okay, so now you realize that we have to be running this program over and then over again in order to make any headway. Okay, and then we can try to fix that. I mean, you can decide to leave it here, but let's just try to fix this. Okay, and then it's going to help in a lot of the future projects that we are going to be doing on this particular chart. Okay, so what we want to do is we want to add a loop. Okay, we want to add a loop. Now, so in Pygame we call this a game loop, but let's just keep this simple. Okay, so to implement any form of game loop, okay, my little experience with game stuff, okay, we want to look at the events that we want to be looping, we want to be repeating. And if we go through our script right here, we can see that the particular blocks that we want to be looping over are from 10 to 18. Okay, we want to be getting the user's inputs, and then they need to try and try again. But you need to still be running all of these checks. Okay, so I'm going to say something like this. I say while true, good, and then we remember our Python, we need to give indentation. I don't know why the IDE did not even flag me. We need to give indentation in order for this to work. Okay, good. So this is a good time to look at all the issues that we have discussed before. Okay, now when we try to loop this and we say while true, okay, this is always going to be true. Let's look at what's going to happen. But what we have done over here in an attempt to loop, okay, you realize that because we are printing, we know the correct answer, right? But anytime we come here and then we are even getting the correct, there is no exit procedures. Okay, let me try to even go higher and lower. So we realize that we are just stuck in this loop, and then it's going to keep asking us and asking us. So this is an example of how an infinite loop may occur. So I can think of two things. We can try to break or pass or something and try to exit this loop. But instead, since this is a game and want it to be trying, let's add an attempt left variable. Okay, then we add this to the logic, and then we say while attempts left is greater than a certain number or less than a certain number. I've not quite figured it out yet. As I go on, I'll be able to see it. But let's just do that, and then we use that as the condition instead of just while true. Okay, so let's just implement that. So over here where we defined a lot of our variables, okay, now you should be grouping your code like this. So I want to say attempts. Am I spelling this right? Who cares? Left is equal to, let me see, let's give them 8 attempts. Okay, that should be enough to make the game at least competitive. Okay, so we have attempts left is equal to 8. Okay, now instead of just while true, what we want to do is we want to say while, then we pick our attempts left variable and say while is greater than 0. So that's literally while we still have tries left. I think, yeah, while we still have tries left. Okay, if we are not greater than 0, it means we are out of tries. Okay, then we are going to go through all of this. Okay, and then we come down here. Okay, but you realize that we are still going to be in the infinite loop. Okay, because it's either we are going to say, so when we had while true, we'll have to set it to false somewhere inside of the logic, or try to break out of it some way somehow. With this, while attempt is greater than or equal to 0, we are not doing anything to the attempts left variable. We have just left it idle. So this is never going to register. Okay, so after we go through all our comparison logic, we want to do our replay logic or whatever. So this is going to be a simple decrement. Okay, instead of plus plus, we do minus minus. That wouldn't even probably work. This is not C++, but yeah. So we want to take our attempts left, okay, and then we say minus equals, let's say 1, okay, all in our while loop. Mind you, I said whatever we want to loop, we want to be doing it over and then over and over again. Okay, now after this, it's just kind of nice to also give our user a message, and then let's use an F string. Okay, so after this, it's just nice to give our user a message. Okay, after all this, so that they can also know what's going on. So what we want to do is we want to say we want to tell them the number of tries that they have left, and that's basically our attempts left. Okay, in whatever part of the iteration it will be. So when you go through the first one, they would have 7 attempts left, then 6, then 5, then 4. Okay, so what I want to do is I'm going to use an F string. Okay, then we say you have attempts left. Maybe this was not the best name. Attempts left. Oh my god. Let me run this and let's see what's going on. So let's try 72. Okay, and let's see. Let me go 23. And then you see we now have 2 low and you have 7 attempts left. Now let me go 90. And now we have gone too high, and we can see that our logic is working properly, it's decreasing and everything. Okay, and since what we just implemented is the attempt limit, let's try to just exhaust everything. Okay, let's do 22 till it's done, and then you say you have 0 attempts left. Then we get to exit our loop just like that. Okay, because now attempts left is not greater than 0. Okay, so that's pretty much it. That's how to implement this. Okay, now if I know this has stressed than your average number guessing video you see, but before I log off, okay, I want to make mention of where we take our user inputs. Okay, as you code, wherever you take user inputs, try to see them as avenues for problems. Okay, and this is just an assignment to anyone who is watching this. I want you to rewrite this program and then also put error handling over here. Okay, because imagine, and let me just try this. Imagine the person does not input any number. Let's say I just hit enter, and we have all these nasty errors you want to think about. And in today's job market, it's simple things like this that can stand between you and your dream job or getting that job. You understand? These are all some simple edge cases. So you just try to think through them and then try to do them. Also try to put it in the comment section. I do my best to read all of my comments. Then yes. Yeah, okay, so that's just by the way. And then we are not done in itself. Okay, this is a bonus section. At this point, you have gotten to a pretty good point in the game, but there's still more we can do. Okay, now when the user loses, instead of just exiting, okay, we can also take a step further and then give them a losing message. Okay, so for that, it also still deals with our attempts left variable. Okay, so we say if attempts left is equal to 0. Okay, it has been decremented to the very end. Okay, then we want to print and give them a message. Game over. Okay, so we give them a message and we tell them that it's game over. Okay, and even with this, let me see. We want to give them an F string, and then when we tell them game over, let's try to also tell them the number. Okay, so the number was, and then we say number to guess. I think good. And then we say number to guess. So we just try to tell them, and let's test this out. Okay, so our goal during this test is to just fail, so the attempts are exhausted. And let's see, let me see 4. We say game over, and then it tells us what the number was. Okay, good. So these are guess, and try to think through this. Put your solutions in the comment section. I like to see what you will come out with. So that's basically it. Okay, and we are at a very good point. But what we can also do to push this a step further is we can get this whole thing to replay, and that's as simple as also including another check. Okay, and you realize that what we did for the attempts left. Okay, we want to create some sort of variable. Okay, and with this one we need a choice from our users. Okay, so let's create a replay variable, and then we say, let me see, we want inputs. This time the input is a string, so we leave it like that. We don't do any integer whatever. So we ask them play a game. Let me see, yes. How do you write this? It's been a while since I coded games. So basically we ask the user, do you want to play a game? Yes or no? Okay, and we tell them type Y or N. Again, if you are following and you are consistent with what I've been saying, anytime we are asking for inputs, these are chances that can cause problems in our programs, can crash our programs. So you can maybe put again some try except here to handle these errors, or you just specifically tell them what you want. They should input Y or N. Okay, now I want to take replay and I want to make it dot lower. I want to keep it in lower case because again users can be weird. Now let's simply check the replay. So we say if replay is not equal to yes, right? That's not equal to Y, I guess. Let me check the string itself. Y, like this. Okay, then what do we want to do? We just want to break. Like I said, that's one way to exit a loop. Good. Now we are not quite done with this part just yet. Okay, we are not quite done because we need to start from here. Okay, because that's what we want to do. So this loop is for the comparison logic, the replay logic, and then the message, blah blah blah. And then we want to start another loop from the higher point. Okay, that's where we define our variables and blah blah blah. So we say while true. Then we want to indent this whole thing by a step. I'm going to exclude the replay, guys. We want to indent it like this. Okay, to kind of fit through. Now let me group these together so you can see that they are one family. And then we have it like that. And at this point, I think I'll get rid of the print so we can actually play the game, right? Good. And let me see if everything is good. Yes. So this replay event, okay, is really working off the top here. And then what we have in here, replay logic, losing message, blah, 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 is working off the attempts left. Okay. So let me try this. Okay, this should work. Good. So to test it out, again, I want to test out the feature. Okay, the replay we just did. So let's just try to exhaust everything. And you can run all of your tests after we are done. So game over, the number was 95. If I want to replay, then let me see why. And it says we go over again. It says enter your number, blah blah blah. And I think the play again message is not very. We can decorate it a bit, but basically we are done. Okay, yeah, we want to put some space over here. So now I've tested the replay. Let's actually try to play this. Let's see how smart I am. I'm going to go for 50. It says too low. Let's go to 60. It says too low. Let's go to 70. It says too low. Let's go to 80. In fact, let's just go to 90. It says too high. Let's go to 85. It says too high. Let's go to 83. It says too high. Let's go to 82. Come on. Let's go to 81. Oh, yes. So, guys, that's a number guessing game in Python. I hope this was fun. I hope this was thorough. And see you in our next project. Welcome. So still on our project today, we are going to be building rock paper scissors. Okay, very simple rock paper scissors game. Now in this one we are not going to be using any external libraries or anything like that. We are just going to make this run from the terminal. Very simple, very easy. Okay, so just sit back, relax and enjoy. So here are some core concepts that we are going to be brushing over, because we are doing the projects to revise. So we are going to be looking at variables, of course, how to define variables, system user input. We're going to be using .random a lot, .random, .choice, and also we are going to be writing some loops. Okay, so that's basically it. Sit back, relax. Okay, so like I already said, we are done with our number guessing game. Let's look at our rock paper scissors. Okay, so before we write anything, let's think about what we really want to do. So we know how to play rock paper scissors, right? We need to write down the rules. So let's see. So in order to play this is the rule of thumb that we have to know. Okay, so rock beats scissors, scissors beats paper, and then paper beats rock, right? So once we know that, what we want to do is we want to go ahead to think through our logic. Now, right now, it's possible that you are just the only person in front of your machine, okay, and you want to make this game. So just like we did the number yesterday, we are going to try to play it with the computer. Okay, we are going to have the computer be giving us values as random. Okay, so that's what we are going to be doing. So we also need a way to have the computer give us output. Okay, make random choices, to be precise, for us. So let me just go ahead and import random. Okay, now if this was your first time writing it and you're now thinking through it, you will have realized you need a random import somewhere down the line. But let me just import it at the top before we start, just as good practice. Now we need to be able to have all these rock paper scissors. Now think about when you are playing it even in real life with your hands, right? You say rock paper scissors shoot. So those rock paper scissors, they are like choices in your head. Okay, we want to visualize them as an object on their own. So we want to create a variable. We say choices, and then we say it's equal to, we make a simple list, and then we say rock, we say paper, and then we say scissors. I hope that's the correct spelling. Okay, let me put them in correct format, like this. This is how it's supposed to be, and then scissors like this. Okay, so once you make out the list like this, now think of what you need next. Okay, you as a user, when you are playing it, there are objects in your head, right? But you needed to make another choice. Now you have to choose from these objects. Okay, so let me just make another variable user, and right in the part, I want you to predict the next variable in the comment section, of course. So we say user is equal to, now we ask for input. Okay, you know how we do it. We ask for input, then we say enter rock or paper or scissors. So we need the user to enter either rock or paper or scissors. Okay, then we want to take this and put it in dot lower, just to be able to do some error handling. Okay, we convert again. Users are aware. Next person want to play against is the computer. So let me see, computer opponent. You're trying to add the comment yourself. Okay, so computer is equal to, now remember this import we made. Okay, so we are going to go random, and if you have never used this before, this is where you go to the docs. Okay, so random blah blah blah, so you can read everything here, but right off the bat you can see that it has something called choice. So they say random dot choice. We want to go for the random dot choice because we want the computer to make a random choice. Okay, so random dot choice, and it needs to take in something. Okay, where are we making our random choice? So we go here, we say that okay, we want to make a random choice on rock, paper or scissors. and that's stored in a variable choices. I should have changed the names a bit. So we have choices like this. So we are just making a random choice on the choices. Okay. Confusing, but yeah. Right after that, we want to write our, shall I call it game logic? Okay. So game logic and win-lose logic, right? So over here, that's where we want to put our rock, beat, paper, scissors, blah blah blah. We want to translate this. We want to write our game logic code. Okay, so before we move on to anything, let's just prove that this particular computer is equal to random.choice. Let's see that it's working, that the computer is truly making a random choice. Okay, so let's just print computer chose computer. We printing this. So let's just print computer choose computer, and we run this. So that's an F string if you remember. So we do this, and then we are going to have, so it says enter rock, paper, or scissors. Let me enter paper. And right now there is no proper error handling or anything, so it doesn't really matter. So it just tells us what computer choose. Computer choose paper. Computer choose paper. And yeah, so that's showing us that it's indeed printing out something. Let me just clean up our input message with a colon like this, and now let's just move on to our game logic. Okay, so let's really just think through our game logic, right? The first thing that can happen is that everyone goes and picks the same thing, so they are going to be equal. Okay, for then it's a tie. Yeah, so the first thing that's going to happen is that both you, the user, and the computer are going to pick the same thing. So in that case, it's a tie. So we say if user is equal to computer, then we print it. We print it as a type like this, because again, it's a type, basically choosing the same thing. Good. Then we come down. We say elif our user is equal to rock. So otherwise, if our user is equal to rock, okay, then you can write this beside you or something. But I want to go back and we refer to this right over here. Okay. So when we have rock, we know that paper beats rock. But what does rock beat? Rock beats scissors. Let's try to address that first. Okay. Now when we do that, we want to nest another conditions because it's two. There are other ways to write it, but let's just start from here. Okay. There are two conditions. So another person pulls rock, another person pulls scissors. So if the user is equal to rock, and if you see, just nest it under. So we say if computer is equal to, if computer pulls scissors like this. Okay. Then we print you win. Okay, and like this we can immediately just handle the negative case for the other way round. So yes, the else we print you lose. Okay, good. So otherwise you win. So either you win or you lose. Simple with the rock scissors situation, depending on which one you have drawn. So we just handle the positive case, negative case. Think back to when you were learning like flowcharts and things like that. Either X or Y. Okay, good. So we'll come down and I want to handle the next condition. Let's go back there and then we'll look at paper. Okay, so we say what? Paper beats rock. So we are going to do the same thing for paper. I hope you are following. At this point, you can pause and write the rest. So paper beats rock. Let's try to do the same for paper. Let me try to copy this. Good. So otherwise, if our user equals to, let me change this to paper like this, and our computer is rock. Okay, so this is going to be covering the second condition. And let's write one last one. All these are expensive parts. Let's write one last one for our scissors when the user chooses scissors. So let me just paste the same thing again, then we'll refer to the logic, then we'll look at it. So we come here, we see scissors beats paper. So we are going to do if user is equal to scissors and computer has paper. So scissors and computer has what? They have paper like this. So yes, If user has scissors, computer has paper, they'll win. If it's the other way around or anything else, they are going to lose. We write another else statement to do some cheap error handling. Let's just try to, let me see, invalid inputs. This is very cheap. You should go further to scrutinize the inputs, but yeah, we are going to do that. That's very cheap, but all the same, everything is fine. At this point, you can basically stop, but I'm going to take it a bit further. Okay, so let me run this. Let's try to see if we have made any errors, unsuspecting errors. So just testing this out, you can see the first one. We went for rock, and the computer also went for rock, so it's a tie. So our logic is working. Let's try some more. Okay, let's try some more. Let me expand our terminal so that we have more space to work with. So let's run it again. And this is another problem we solve soon. You always have to run it every time you want to test this thing. So let's go for paper. Okay. And say computer chose scissors, you lose. So you can see that all our conditions are working, mostly working. Now let's go for scissors. Okay. And you can see that the computer also chose scissors. It's a tie. Now all these are as random, just like we defined in the code. Okay. So let's take it a step further. Now this is very, very ugly. I wrote it this way for understanding. Okay. And there's a lot of nesting over here, right? So I just want to clean this up a bit. So yeah, let's just try to rewrite this with end. I mean, when I was explaining English, you said English, you can see that I said if user is rock, and if user, that's just why we nested. So let's just use the end keyword instead of nesting it, and yeah, makes it shorter and also optimal. Yeah, so let me shrink this. Okay, so we say if user is equal to rock and computer is equal to scissors. Okay, good. Now what we want to do is we want to, should I say, compress all the winning conditions. Okay, so we want to just handle all the winning conditions before we even talk about the losing conditions. So what's our next winning conditions? If user is paper and computer is rock. Okay, yeah. So we want to handle all the winning conditions. Let me clean this up. Okay, and we are going to be doing something interesting. So let's put each winning block in brackets. Okay, to help us and also the IDE. Okay, this is going to help us, both us and Python, to be able to segregate everything. So we have gotten one full block. Now let's look at another block. Okay, then we see or, then we look for another condition. Let's go and check it. So let's do paper and rock. Paper beats rock. So for that to happen, user is going to have to be equal to paper, then computer, and then computer is going to be equal to rock, like this. Okay, or what have we not done yet? Okay, user has chosen rock, user has chosen paper, then we do scissors, I think. Yes, so when user is equal to scissors, scissors beats what? Let's see, scissors beats paper. Yeah, I think. And computer is equal to, let's see, paper. Yeah, so this is the full line. Okay, this is going to be our full line of our elif. It's a full line, and now you can write whatever you want to write under it. So we just print you win. So this is what we want to write it to look like. Okay, so like I said, we bundle all the winning conditions, and then we just say that if you get any of that, you win. Otherwise, you literally lost. So just you lose. Okay, so again, you just go through this guide over here. You do for rock, you do for paper, and then you do for scissors, and then you can get the condition like that. So once it looks like this, okay, let's just add an extra step. We still want to check for the invalid input thing. Okay, so if user not in choices, then we just print invalid input or something like that. So we say invalid inputs like this. Good. So you can see you have tested out a bit of the logic point. So paper is a tie. Then look for one where I won. So rock paper, I lose. Paper beats rock. Let's look for this one again. Rock paper I lose because paper beats rock. Okay, so everything is looking so everything is looking good with our logic right now. Okay, so yeah, basically we could be done. But you realize that anytime we want to test anything, we have to go and then we run. We literally click run, and then we have to do this over and over and over and over again. And they have to pop up, and they have to write over and over again, right? So no, we want to introduce what we call a game loop, just like in the other projects. Okay. So for the game loop, whenever we want to place a game loop, we want to think about what we want to be repeating. Hence the word loop. Okay, we want to think of what we want to repeat. Now we look at this over here. What do we want to repeat? So this itself is like a distinctive object. Okay, it's an object on its own that we created. The choices were not object, but variable on its own. So it's a separate entity, and we do not really want to be. But think of what we want to be repeating when we are doing the game. Okay, you want the user to put their inputs over and over again. You want the computer to make the random choice over and over again. You want the checks to come over and over again. Is it invalid input? Is it a tie? They win? They lose? All of these we want to happen over and over again. So we come and we say while true, like this. Good. And then we want to nest everything under it. So we just hit tab, and then we have been able to just tab it like that. Good. So now that we know what we want to repeat, okay, when we run this, it's going to be truly just repeating that. It's going to be spamming it over and over. Like, think about it. So in the number guessing game, we have to make exit conditions and all of that. But no, this one, we literally just want the user to play until, because of the way rock paper scissors is. So you can see the last thing computer chooses rock. Okay, so let's predict it takes a rock again, even though it's random. Then let's also go for paper to try to beat it. And it says computer chose paper, it's a tie. So yes, you can literally just let's go for paper again. And computer chose rock, I win. Okay, so that's how this is going to be. You can just keep it in a loop. You play until you knock yourself out, and then when you're done, you literally just trash the terminal. Okay, you just trash it, and then you should be fine. Okay, yeah. So that was rock paper scissors. At this point, you can call it a day. And also just an assignment for you that's watching. Okay, in the comment section, you can try to track scores using the computer score, the user score. So let's say if any of the winning conditions hit for the user, you increment the variable you are using for the score. If the user loses, that means the computer won. Then increment them to their score. Like, yeah, mess around with it here. So this has been rock paper scissors, and I'll see you in the next one.
If you are still watching this, you have officially conquered the fundamentals of Python. Built algorithms, handled data. You've learned about data structures, loops, lists, tuples, and what have you. You've even built some games. But let's be real, who wants to play in the terminal forever? Absolutely no one. So you've mastered the text, and now let's build something visual. Like you saw at the very beginning of the video, we are going to be building a Python racer, an actual racing game. So we are stepping completely out of the terminal. I'm going to introduce you to Pygame, and we are going to build a fully functional visual 2D racing game. We'll handle loops, state machines, and real-time keyboard inputs. Let's finish this masterclass strong.
Obviously, you can actually add the PNGs, you can add the pictures and things, and then make actual cars. But this is where we are going to leave it. And once we actually start the Pygame course itself, then we are going to learn about all those things. After learning object-oriented programming and all that kind of stuff. So let's create our racing game using Pygame, right? Now let me get rid of these. Let's just focus on our racing game. Okay, now we are going to be using something we call Pygame. So it's an inbuilt, it's like a game engine. It's not exactly a game engine, but it allows you to make games using Pygame. Okay, now we're going to go in depth into this. We're going to make a whole tutorial. Okay, so this is just like an introduction at the end of our main Python course, and then we can later move into Pygame having had this experience. Okay, good. So first thing you want to do is to import Pygame. Okay, because that's what you're going to be using. You have to import it in order to be able to use it. Next thing you want to really do is you want to create the window. So you want to create your window that everything is going to be taking place in, because the Pygame we are about to make is going to be displaying inside of a window. So you want to get your window size down and all those kind of stuff. Okay, so here's what we want to do. We want to initialize Pygame. So we say Pygame.init. That's going to help us to initialize the whole thing, initialize Pygame. Now we need to think about two parameters for our window, for our screen. Okay, and that's our width and our height. I'm going to explain this in detail when we start the course. So I'm going to be explaining in detail in the actual Pygame course, but bear with me. This could get very long if we try to do that. Okay, so we say 500 and then we say 700. Okay, so as you saw, I've already made the king. This was due to some tests that I have conducted. Okay, when you are building, you might have to play around with some of the figures and see what works best for you. So we want a width of about 500 and then want a height of 700. Now, since the height is longer, you can think of how it would be. So let's see, an S24 screen, like the vertical part is going to be longer. Okay, that's what we are dealing with. Then what we want to do is we want to focus on our screen. Okay, we want to focus on our screen. So we can say our screen is equal to, now we use our Pygame. Now Pygame has something it calls display. Okay, we want to set the display mode. So we say display dot set mode like this. Good. Now what do we want to display on our screen? We want to combine our width we just made over here, and then our height to get our display. Okay, good. So if we look at the set mode, I think what's in the brackets also has to have brackets, see if that makes any sense. So let me just keep this in brackets. Okay, then with that you have been able to deal with the screen. Now also something we can do is we go Pygame again and we want to go to our display again, once again, but this time we are not setting mode, we are setting, let me see, our caption. Okay, so we set our caption. Let me see, which caption do I want? Let's just call it racing game, like this. Okay, so we've been able to set our display mode, our screen parameters, and then the window itself, and then this is what we are going to have. Okay, so that's a good starting point. What I want to do is I want to create a game loop. Okay, now if you have been following the course, you should be familiar with the game loops. So this game loop is for us to be able to create, like, should I say, a quick event. Okay, and also to just keep things running over and over again. Because think about it, a racing game, cars need to keep coming, but almost any other game. Okay, so let's just make the gaming loop. While true, you know what, for more control, let me keep a variable here. Let's call it running, and let me just set it to true like this. Okay, and then we say while running like this here. I think this is better. Okay, let's do it this way. Now for event in Pygame, again, our Pygame has events, I think. Good, and I want to get the specific event you are talking about. Good. So Pygame works on something called events. Okay, so for all the events, if it's a quick event, so let's say if event dot, so if event dot type like this is equal to Pygame dot quit. So if it's a quit event, like I was saying, then we want to set running to false, so that we can just break everything we are doing. Again, that's some of the essence of the game loop. Alright, yeah, so if we are able to set it to false, then it is part of the essence of having what? A game loop. Okay, good. Then finally, what you want to do is you want to do screen.fill. Okay, now I want to add some, I don't know the specific color, but let's just do 50 50 50. It's, I don't know, some slate gray-ish color. Let me just, yeah, so at the end of this, Ideally, you should be able to display a window, like I said, a phone-like window. Let me run this. Hopefully, we do not have any errors, and then we'll be able to have our window displayed. I think this is just like this. If my memory serves me right, this should also be double. Okay, let me just do that, and hopefully we don't get any errors. Okay, yeah. So this is just a color value. Okay, this is just a color value. Yeah, good. So as you can see, this is our game window. Okay, so we are going to be making the rest of the racing game. Everything about the racing game is going to be in the confines of this window. And if you quite remember, I told you we made the height longer simply because we want this part to be longer so that we have more room for the racing game itself at the top there. Okay, so width of 500 and height of 700. Yeah, it just uses to kind of visualize, and then you'll be able to be fine with Pygame like that.
So if you're finding this video in any way helpful, I suggest that you give us a like and then you hit the subscribe button. It's going to help me and the team to keep on making massive courses like this for absolutely free. Also leave your thoughts and opinions in the comment section on how we can improve these courses. And yeah, let's get back to the video.
So that's very good. We have been able to see our game window. Okay, now let's work within our window. And I would like to mention this. Things could be more simpler and more innovative if we're able to use OOP. Okay, you could give it a lot of properties and things like that. But let's just keep working like this. Okay, so now what we want to do is we want to create our road lines. Okay, so let's see, create road lines, so more of position. Okay, Pygame, we deal with positions. Again, I'll explain those in detail in the actual course. So let's create a variable road lines. Let's leave it like that. Okay, now I want to set it to an empty array. Okay, we want to keep road lines in an empty array like this. Okay, good. Now we want to see for y in range. We want to give a range. Okay, now this particular range we want to start from 0. Okay, then we want to go to our height. Okay, now I want to include a step of 80. Okay, then we say road lines dot append y, like this. Once we show it on the screen, I'm going to go into more details. Not more details, I'll give you an overview. You'll be able to understand it. Again, more details will be in the Pygame course itself. Now let's look at what we wanted to avoid. So if I wanted to create the race lines, instead of doing something like this, instead of like hard coding maybe some string or something like that, we want to calculate like based on the position to now get this actual line. I don't know if we can see. Okay, instead of imagine it in the window, so this could have been the divisions in the road, but we don't want to do that. We want to calculate it based off like actual positions. Okay, good. So that's why we are doing that. I'm anticipating that this mistake might be made. Okay, so we want to keep almost everything. We want to keep everything inside the game loop that we have created. Okay, let me send this back in size a bit. Okay, we want to keep it inside the bounds of everything that we are doing. Okay, so let me just paste that over here. Good. So this should be within the bounds. Okay, good. So we have done this. We have determined the positions of the lines, but nothing is going to show yet. That's how Pygame is for you. Okay, so nothing is going to show yet. We actually have to draw it. We have to display it on the screen. So if you have been working with Pygame, you'll notice that I did not update the display. Okay, that's because we have to add this. I want to add this. Okay, I want to draw the lines, the road lines. Okay, so for y in road lines like this, then we say Pygame. Now Pygame has available to us a draw method. Okay, so draw, and then we see dot. What do you want to draw? We want to draw a rectangle. So Pygame dot draw dot rect. Okay, good. Now what does this particular one take in? Let me break it down like this so that we're able to see it. So I always tell us to be looking at this particular documentation inside of VS Code. Okay, so it takes in a surface. Then we want a color That's we put a color value and then the rectangle value. Okay, so that's what I'm about to be doing. I know the numbers part can get confusing, but this is simply the surface. Okay, so the surface, where do we want to put it? We want to put it on our screen. Where is the screen? This screen that we made. Okay, we want to put it on this screen that we made. So we need the surface, the color value, and then the rectangle value. Okay, so we are going to say screen, like I said, then we need 255, 255, 255. If you started coding today, I think everybody knows this. This is white. Okay, this is the RGB for white. Yeah, so that's white. So we want the lines to be white. That's the color value. And then finally, we need our rectangle position. So we say 240, and we say Y, and we say 20, and then we say 50. Again, I'm going to try my best to explain this, but we'll go into more details in the actual course. I'll do my best. Okay, good. So now we have actually draw the lines. And finally, let me add one update before the screen fill. We say Pygame. Is that right? Pygame dot display, and we say dot update, like this. Good. And now when we run this, we should be having our lines in the middle there. Yes. Yeah, so as you can see, we have been able to display the lines in the middle over here. So the next thing we want to do is we want to get these lines to be moving. Okay, so let me just try to explain this before we log off, and then we come back to do that. We are not moving the car, we are moving the board, we are moving the screen itself. Okay, so we just want these lines, we animate these lines instead of animating the cars. Okay, so the car itself is going to be like static, and this animation is going to create the illusion of the car moving. That's how this 2D ring, I think even endless run is, that's how the principle is. That's the principle that you want to work on. Okay, so let's move on. Now what I want to do is we want to actually get those lines to move or look like they are moving, depending on who you ask, if you want to go into details. Okay, so what I want to do is at this point I want to add in a clock. Okay, now let's think of it like we'll be using this to control FPS. Let me put it like that. So you see clock is equal to Pygame. Now Pygame has available to us time. So you see dot time, like that. See dot clock. We want the clock. Okay, so like this. So let's think of it like we have initialized like the variable, and then we are going to be using it later. Good. Then we want to come inside of the game loop. Okay, we want to come inside here. Then we want to set the actual tick of the clock. So we say clock dot tick. And what do you think? I said FPS, so what do we really think? Let's just go 60. Okay, let's go 60. I think that's a standard. That's a good standard to start off, regardless of your machine or whatever. Like clock dot 60, that should be able to work for you. Now the next thing I want to add is the actual code that will let the road lines itself move. Okay, now if you want to think about it, I want to make sure you understand where do you think this one is going to go. So if you study what's going, anything that involves changes like over and over again, I mean, think of frames per second. We want to display the first frame, second frame, like it's something that's continuous. Okay, if you look at this, we want to draw the road lines. It's something that should be rendering and then keep rendering. If you want this to move again, we want it to keep doing it over and over again. So that's some way you should think of deciding what goes into your loop and then what stays outside of your loop. Okay, let me see, moving your lines, if that makes any sense. Actually, it makes sense. Yeah, so moving your lines. Now again, we want to say for I in range. Let me see. Now I want to take the length of our road lines. Okay, yes, the length of our road lines. Let me say it like this. Good. Then we want to say road lines at 1. Again, I'm going to be trying to explain this. So if you pick an array, we know that the position, we know that index 1 is position 2. Okay, so in order to be making our illusions, we want to be working off the second position, and then we just be making our movements like that, if that makes any sense, because we want something that's continuous, so the movement is going to be occurring in thereabouts. And that alone is not it. We are not done. We want to say if our road lines at I, okay, good, mind we are looking through everything with I. So if our road lines at I is greater than our height, like this, okay, then road lines at I, we want to decrement it. Okay, so minus equals, and then we say 50. Okay, good. So we want to decrement it by 50. Now, again, for me to explain, let me try to run this. Okay, we want to change this side to here, so you can see the movements occurring. I think it's quite fast, but yeah, so that's the movements that are working off. And you can see once we have something over here, right, if we have something over here, it's going to create the illusion of like movement. Okay, so that's what we are working off right now. So we have been able to make the movements. Let me see if I can get it to slow down so that we appreciate it. And if you really think about it, you can see that we started from index 1, right? This one is always set in place, and then we do our illusions over here, as you can see. So we render here, then it leaves, then we render here, then leaves, then render here. You see how it is. Okay, so that's how to move the road. Let's just keep this at 50. Okay, now we are going to make ways to control like the speed. Now the speed itself is going to be coming more from the car side of things. Okay, because what we just did again is just like an illusion. Okay, to create the illusion of movement. So the speed itself is going to come from the car side. So the next thing we are going to do, we will add the player. We'll add the player being the car. Okay, so next we are going to add the car.
So if you're finding this video in any way helpful, I suggest that you give us a like and then you hit the subscribe button. It's going to help me and the team to keep on making massive courses like this for absolutely free. Also leave your thoughts and opinions in the comment section on how we can improve these courses. And yeah, let's get back to the video.
So let's go ahead to do that. Okay, let's go ahead to add the car. Now to do that, you want to end. Let me just take this time to say this. Okay, so in Pygame, it's a 2D engine. Okay, so we are working off width and height. Okay, let's just keep it in our minds like that. We are working off of 2 dimensions. Let me just keep it like that. So yeah, so in most of the objects that we are going to be creating, we are going to be needing those 2 dimensions. Okay, so in attempts to create our car, we are going to need a car X and a car Y. Okay, good, like this. So we want X to be 220, okay, and we want Y to also be 550. Now again, these are things I tested off screen, but let's keep it as the same principle. I said it's going to give us a phone thing, and if you think about it, Y means like Y is a vertical part. Okay, so the car is going to be like a bit long. Okay, like that's how it's just going to be. Then we are not done. We want to do for the width and then the height. Okay, so we say car width is equal to, let me see, I've forgotten. Now car height, if I don't remember the test, I'll just use anything. Let me see, I think it was 60. Yeah, this should be 60, and again the height has to go longer than it. So let me give it 100. Let me give it 100. I think that's right. The difference is 40. Yeah, I think that's right. Good. So let me add in a comment here that says add player car, like this. Okay, so this is what we need in order to be adding the player car. Again, this is just the position aspect of things. Okay, so we have to now draw this car to just like the way we added for the lines. You can see it's over here. Then, so let me put it here. Let's say position. Okay, Okay, then we actually have to go and draw it inside of the loop. Okay, so we drew our lines, we move our lines. Let me now draw the car. So see, drawing our car like this. Good. So what do you want to do again? Oh, I wish I grouped the drawings together. So we just say Pygame dot draw dot rect. Again, that's the shape we want to exploit. We want to use a rectangle. Say Pygame dot draw like this. See dot rect. We open it up and we open it up again, just so we'll be able to see that much better. Okay, now Pygame dot draw dot rect. Let's go through again. We need a surface that is going to be our screen. We need a color value. I think I'm going to use red. I think I'm going to use either red or blue. And then we also need the rectangle value. Okay, just like we did for this one. Yeah, so let's go through that. We put screen over here. Then the next thing we need is our color value. Okay, then we want to say 255 0 and then 0. Okay, even if I've been coding for this is just red. Like you see, it's RGB. So if you tune out the rest of the numbers, it just means you're left with red. So ideally, this should give you red. This is the color code for red. Okay, here. So finally, we want to put our rectangle value. Okay, now our rectangle value is going to be a combination of these positions we have here. We are going to use these positions to form a rectangle. So you can think of it like a rectangle has 4 sides, right? So you're going to make use of all of these to achieve those 4 sides. Again, I'm not going to be explaining in detail. If you're more interested in Pygame, you can catch me in the course. Okay. So we start from car X, then we go to car Y. Again, if you are confused, you can just do what I did. You see the particulars of the rectangle value. In fact, I may go through it as. And then we want our car height. Like this. Okay. So this is what we want to utilize in order to be drawing our car. So let's run. And then we'll be seeing everything coming to life just like that. We're going to see the car itself. So I think we can see that. Okay, so we have been able to render this small box. Okay, and at this point you realize that I've been talking about car, I've been talking about road, I've been talking about all we see is 2-dimensional shapes. Okay, that's because in the under workings on the under layer we are working off the shapes. Now what you can do is if you move forward in this thing, you can do what we call like sprites, even more complex animations than this thing I've done. Okay, and you'll be able to swap the assets like that. So if you perform an asset swap, this can be like a car. So you find a top view of a car in PNG format, and then you'll be able to swap it. But once again, if you want to deal with all those stuff, you have to catch me in the Pygame course. Okay, yeah. So this is it. You have been able to add the car. The next thing we want to do is we want to be able to move this from left to right. Then we also think of other cars, so obstacles that was going to interact to us to just make it a bit more fun, and then we can double up from there. Yeah. So now let's deal with the game controls. Okay. Now I want to add this right under the events. Okay. So Pygame has made provisions for us to work with these controls. Okay. Now we need to do like some kind of initialization. So we'll go through the keys. We say keys equals Pygame dot, let's say key dot get. I'm forgetting this thing. I think it's get pressed. Good. Get pressed, and then you add a bracket like this. So this is like some initialization that we are doing. Then what we want to do is we want to say if, okay, then we say our keys, we make a square bracket. We want to say Pygame dot key left. Okay, so the two keys I want to be using is the left arrow key and the right arrow key, and I think that's key left and key right. Oh, I remember. You're supposed to use a capital key. Okay, key left, key right, but they still mean the same thing. Okay, yeah, all right. So it still means the same thing. So if you are hitting the left key, what do we do? Let me say it like that. We want to take our car X, okay, and then we want to, let me see, left, we want to decrement it by 5, okay, like this. Then let's go again. In fact, let me just copy it, like, let me be a proper programmer. I'm going to copy this and edit it, right? So let's copy and let's paste this, okay. Then we want to change this to right, because this time we are dealing with the right key. So we say right, good. And this time we want to increment it, okay. Now I'm going to be explaining like shortly, so don't worry. I want to do one last thing, but I think it will be good demonstration. So let me just run the window and then we are going to show it. Okay. So let me just run this. Let me run this. Okay. So as you can see, we are moving a bit. Okay. I want us to pay attention to what happens when we get closer to the walls. You see, we are entering. We are basically entering. Okay. And it's basically boundless. You can move and move and move and move. So we do not want that to happen. It looks weird. It looks like a bug. Okay, it looks like something we didn't see. So we need to fix that. Okay, and what we want to do is, so let's say this is a 0. Okay, I always explain this using a graph. This will be 0. Let's see, 1, 2, 3, 4, 5 up to the top there. Another 1, 2, 3, 4, 5 up to here. Okay, now again, let me explain this part of what we did. So over here, right, when we said car X, if it's left, we want to decrement by 5. Okay. Again, if we use my number line theory, wherever we are, when we decrement by -5, it's going to take the number lower. Imagine it's 1, 2, 3, 4, 5, 6 from left to right. If we decrement by 5, 10 now turns to 5, and 5 will be this way on the line. So that ends you moving this word. On the other hand, if you increment it, go to something like 15. Now 15 will be found on this far side. I wish I had a whiteboard. I'll explain better. Then we move like this. So that's just how the movement is. So we are simply saying, okay, when we hit this wall, you want to reset it to the bounce, the value that the bounce has. And over here, to want to reset to the value that the bounce has. That's one way of keeping everything in bounds. Okay, so let's just look at how that's going to be done. So still right around the controls, we want to say if car, okay, car X is less than 0, then car X is equal to 0. From my explanation, we kind of know that the starting point of the viewport, okay, the starting point from the down there, we kind of know that it's 0. All right. So once we hit there, we want to just reset it to 0. It makes sense. But for the other side of things, you realize that the dimensions, that part is the width. This part is the width. So we would have to use our width variable over here to be able to get those bounds. Again, I may not be going into too much detail, but catch me in the Pygame course and you'll be fine. So again, we say if car X, okay, then we say is greater than the width. Now we are using capital width because it means that it has exceeded this our width. Okay, imagine you are going out of the screen I have set for you. Or what are you doing? Okay, so it has exceeded that, right? Now we are not done. Now when it has exceeded that, the car itself is a body. It itself carries values, numerical values that we give to it over here. Okay. Now we want to say, okay, now when you have crossed it, you have added your body weight of 60 to it. You want to take it back. You want to subtract it, and that's how we will get you within bounds. Okay, good. So these are the conditions that we want to hit. Then we say car X is equal to, we want to set it to the width again minus the car what? Minus the car width, because we want to subtract it. Okay, we don't need a colon here. Like this. Okay, So this should be able to handle like for both conditions, like for the left. So this is going to, let me see. Let me say this is left bounce, left wall. Let's call it left wall. I think there's one DSA problem like that. Yes, I think it's a spiral matrix. So let's see left wall, and then let's make this right wall. Okay, and then we want to run the game again to see where we have gotten to. Okay, if truly we are within what? We are within bounds. Okay, yes. So you can see that the road itself is displaying. Now let's try to do the movements again. Now I'm going to near the walls, and you can see that we are tight there. It's almost even perfect. I mean, we wrote perfect mass, okay. And then we go to the right side, it's still almost perfect. You see, so we wrote perfect mathematics. And by that way, we are able to keep the whole thing what? Within bounds, okay. Now what we want to do is we want to create obstacles, like I said. So the next thing to do is to create obstacles that will be moving through. You know how your standard endless racing game is, and you try to dodge them. Okay, so next we have to deal with the enemy car logic, and we'll look at that soon.
So if you're finding this video in any way helpful, I suggest that you give us a like and then you hit the subscribe button. It's going to help me and the team to keep on making massive courses like this for absolutely free. Also leave your thoughts and opinions in the comment section on how we can improve these courses. And yeah, let's get back to the video.
Okay, so let's go on to add our enemies. All right, now if we think back to a few lessons ago when we're doing the rock paper scissors, okay, think about how we want the enemy cars to spawn. You realize that we would need stuff to be happening at random points on the screen, so we want them to be spawning at random positions. Okay, let me put it that way. We want them to be spawning at random positions. Okay, now in light of that, what am I getting at? I'm getting at the fact that we should just import random. You can use this before importing it. But now once we have done that, we need to create variables for the enemy cars. Okay, just like we have for this car over here. Again, I said it's 2D, so 2 dimensions. We are going to have an X, and then we are going to have a Y. Okay, so let me see, where do I even put this? Let me put it before the clock. Let me see, enemy car. Let me see, enemy car positions. All right, good. Now I have something like this. What we want to do is we want to see enemy. So here's why it's good to group your code together. So we want something like enemy car. In fact, let me just call it enemy. So enemy X, like car X, okay. And then we want enemy Y. That'll be like car Y. Okay, that's very simple. And now what to actually do with it? Once again, we have imported our random, okay. We need a random position, okay, between, again, these numbers we are working with, they are integers. So like, yeah, you see rand int. So we want a random integer between 0 and the width, okay, minus 60. Now I hope you followed the whole explanation I gave when we're preventing the out of bounds moves. Okay, when we're doing the left wall and the right wall, I hope you followed all those explanations. Like, think about it. So the width makes the horizontal part of our screen, the smaller part. We want to find somewhere within that horizontal section. So anywhere between 0, this just means anywhere between 0 and then the other wall, left wall and right, or anywhere between the bounds be spawning at a random integer. Now integer because these will be formed by, should I say, coordinates. Okay, so just form a random integer that will determine the position, and then yeah, and they want to see enemy at Y is equal to, let's see, negative 100. Okay, good. And with this, well, not exactly in bounds per se, this technically even, should I say, out of bounds, but like coming from the top there. Okay, so in the loop, what we want to do is we can be increasing this to create the illusion. I think that will be determining our speed. All right, so let's come in here and let's work off something. Okay, so we see enemy Y, and let's just try to be incrementing it. let's see, by 7. Okay, so this is just going to be determining the speed by which it's coming out. So again, we are going to write a similar check to keep this in bounds. Okay, so if enemy y, like this, enemy y is greater than the height, okay, then we just set enemy y back to the starting point. That's, let me see, negative 100. I believe that's all we did. Yeah, so we just set enemy y back to negative 100. Then again, we need to deal with enemy x. Enemy x, like this, is equal to, say, random dot rand int. When we say 0, the width minus 60. Again, just standard stuff to keep all the spawnings we are doing inside our screen. Okay, let me put it like that. Okay, we want to keep everything inside our screen. So finally, when we have done all this, again, we are not done. This is all just logic. Okay, this is all just logic. So we want to come to where we draw stuff, and then we want to draw, let me draw it here. We want to draw our enemy. Okay, that's the enemy cars. Again, we just need to follow those specific patterns. Okay, to say Pygame, where's Pygame? Dot draw. What do you want to draw? We want to draw a rectangle. Again, now once again we come back to the fact that our rectangles, it takes in a screen color value and then the rectangle value itself. So let's see, screen, that's taking a screen, it takes in a surface, sorry, which surface we want to put it. Okay, then for our color value, let's see, I want to give it a blue color. Okay, so we know that the wheel is RGB, so this is for our red, this is for our green, this is for our blue. So if we tune out the rest of the colors, we will automatically have red. Okay, that's if we fill only RGB, we will automatically have blue. So we'll say something like 0, 0, and then we fill the blue, let's say 255. Alright, this should give us blue. Okay, good. And then finally, over here, we want to say enemy, like what are we drawing the rectangle with? We are drawing it with our enemy x and our enemy y, and then 60, 100. Okay, good. So again, this will be, should I say, the dimensions of it. Yeah, so these dimensions are like identical to the ones we have for the car width and then the car height. So if we want to be more, we can just put in these variables instead of the hard code, but I think that will be fine. I think that's fine. Yes, so you realize that both the enemy car and the player car will be similar in dimensions. Let me put it that way. Okay, so now let's run this and let's see our enemy car in action. So we'll have blue and then we'll have red. Yeah, so you can see the spawning is happening over here. And it's going to be happening across random points in the thing. But as you can see, just pass over it. There will be no collision. We do not want this. We want to do it in a way that when there is contact, okay, between the enemy car and then our player car, like there's some consequences, like game over or something. You know how the racing games are. Yeah, so that's basically what we want. So we want to implement collision detection next. Okay, then work off that. We used to have our score logic, we'll have all of that, and I think we can call it a day. At this point, we are close to being done with this. Okay, yeah, so that's what is next for us. Now we want to add the collision detection. We now have the enemy cars and then the player car, but it collides. Okay, they pass through each other and things like that. We want to handle it. And what I'm thinking is that we want to make the rectangles. Okay, we want to make variables for the rectangles to represent both factions of the cars, the enemy and the players. And then Pygame has made a provision for us. That's why I keep saying engine. You still have to do a lot of the heavy work, but they still make provisions for us, and that's what we are going to be using to check for the collision. If you think about it again, we want to be handling this in the game loop. I just can't seem to settle on where. Let me put this right after the keys. Okay, but these are loops. Okay, here. I was still putting variables here. So let's make a player rectangle variable. I know how to type. I don't know why I keep looking on the keyboard. We want to make this. Okay, then we want to say Pygame. Now we are still going for the rect. Okay, Pygame rectangle, and then we expand it. You know how we do it. Now we want this to take in our car X, our car Y, like this, car X, car Y, and if you are someone who pays attention, you can just notice that this is just what we are doing. Okay, to form that rectangle, we also form one for the enemy, and then we'll use it to do the collisions. Okay, we say car, I believe width. Okay, and we finally go for our car height, like this. Good. So that should be that for our player rect. Now guess what we are going to make next? We are going to make an enemy rect. Okay, like this. Then we want to open it up. We say pygame.rect. Okay, good. Now notice how for this one we are not using pygame.draw.rect. We are just using .rect because we just want to establish the rectangles and use them for collision detection. So enemy X, enemy Y. Okay, and then for the last two values, I believe this was hard coded. Let's go back to where we drew the enemy car. Okay, let's go back to where we drew the enemy car. You can see that for the last two, we just made 60 and 100. How else we put this there? I mean, they are both identical, but at the end of the day, yeah, we hard coded this. I don't know, it doesn't make sense to have different variables for the same thing. It also doesn't make sense to put the player cars variables inside of the enemy. That's just pollution. Okay, so let's just keep it hard coded. 60 and 100. So you say 60, comma, and you say 100. Good. Now that we have this, okay, Pygame has made provisions for us to be able to do this collision detection. Yes, that's why I keep saying game engine, because you still have to do a lot of the work, but it's not that bad. It's not that bad. So now we say if player rect, okay, then I think we have a collide detect, something like that. Okay, actually it's not just air. There are lots of things you can do with collide. Oh, okay, I think I have to read the docs again. I think this is what I want. Okay, then what are we comparing it to, or what are we detecting it with? We want the enemy rect. Okay, so enemy, good, I want this on the enemy rect. Now if this happens, there are a number of things we can do, but for now I just want to set my running to be equal to false. Okay, mind you, we have conditions for what should be done when our running becomes false. It's just going to destroy the window. It's going to destroy all windows. Okay, so that's how it is. We can just test this out. Let's test this out. Okay, and you can see over here, I'm going to dodge a bit. Now I'm going to keep it in the center, and you can look at what happened when boom. So as you can see, it just closes the window. You can do other things with it, and I think that will be my assignment to you watching this. Try to play around with it. Okay, you can do creative things with that. So that's our collision detection. Our game is almost done, but we need to add score detection. So that's what we are going to do next.
So if you're finding this video in any way helpful, I suggest that you give us a like and then you hit the subscribe button. It's going to help me and the team to keep on making massive courses like this for absolutely free. Also leave your thoughts and opinions in the comment section on how we can improve these courses. And yeah, let's get back to the video.
Finally, let's add some score tracking. Okay, then we can leave it as a good place, as a place that we are proud of. Yes, and then you can experiment on your own or whatever you'd like to do. So let's say score variable, score var for tracking, like this. Okay, I want to set this to 0. Now you just know automatically that your score is going to be accompanied by a font. It's going to be rendered by a font. So let's just create also a font variable. And for this, you are going to say Pygame dot font dot system font. Good. The sys font. Now I didn't think of any fonts in mind, so I'm just going to leave this none. And for size, let's give it 40. Let's give it 40. Let's give it 40. I think that's a good size. Good. Now with this, we still haven't done anything. Okay, this is not what we really need in order to display it, but let's handle some more logic before we think about when we want to display it. So let's come over here now inside our loop. Okay, now right after this key is pressed over here, okay, right after this, I want to be incrementing the score. And it's very simple to do this in a racing game because I know if you have played some of these before. Back when we had those keypad phones, the score just keeps going slow. In fact, in light of that, one is going to go too fast. Let's make it 0.5. Okay, even that may be too fast, but let me see, 2.5. Let's start from 0.5. We'll troubleshoot and we'll see if it's good for us. Okay, now finally, we are still not done. We want to draw the score. So let's come to where we did our drawings. Draw. And let's try to draw our score. Okay. Now we want to create a variable. We say score text. And then we use our font that we created. We say font.render. Good. So you can see that it takes in text, it takes in the bool, and it takes in the color value. Okay. So let's just get working with that. So now I want to render the score itself, but we want to accompany it with some text. So let's use our f strings. You should be fine with f strings by now if you are taking the course. So you see score like this. Now we say comma. Which boolean do we want? So we want true. Then our color value, we want white. So we just populate all the R, then the G, then the B. This will give us white. Okay, good. Now we are not done. Why? Because if we look at this is pygame.draw, and this time it's just core text. We are using fonts.render. So in place of that, we want to use our screen.blit. We want to blit it. Okay, so it says screen.blit. When I say blit, you just take it like I'm saying display it. So it says screen.blit. I want to take in our score text that we just created. Okay, and then we also want to give it a position. Now the position I've chosen, maybe you'd have to do some tinkering, but I just know. Maybe as you do is from your intuition may grow, you just know how to be placing this. But yeah, this is the position I want to put it. And now finally we can just test this out. Everything looks good. Let's test it out. And boom. Okay, so you can see I suspected this. You can see the scores are moving quite fast. The whole thing itself is not really challenging enough, but you can call it a day. Now let me address this again. I know that we are just seeing some couple of boxes. I'm saying racist game, but if we really want, we could put some sprites and let's say more animations and stuff. But this is part of the Python course, so I don't want to do that just yet. Okay, if we really want to see that, we should catch me in the Pygame course, because I'm going to be making a dedicated course, and I think early followers of the channel even followed for that particular content, like the Pygame course. So yeah, I think I can do this all day. It's not challenging enough. Again, that can be an assignment to you. Focus on how you can make this more challenging. Maybe slow down the score. Maybe adding some restart message. I mean, yeah, play with it. It's your own project. And if you're able to follow to this point, thank you a bunch. I hope you left a lot of likes and comments and shares, and also mostly that you got value from this and your Python skills were improved. Yeah, it's been a blast. I'll see you in the next one.
Take a deep breath. You've just survived hours and hours of intense fundamental software engineering. Think about where you started at the beginning of this video and look at what you've built. An actual visual racing game. Now, you didn't just memorize Python syntax today. You learned how to handle data, write unbreakable logic, and think like a real developer. You're officially out of the beginner stage, so what's next? The training wheels are off. Your next step is to dive into object-oriented programming, connect to external APIs, or build even bigger games depending on the path that you follow. Now, for everything that I have mentioned, there are going to be more tutorials on the channel, especially for object-oriented programming and then building APIs. I'm going to start with Fast API, but we're still going to dive into a whole other range of languages. If this masterclass finally helped coding click for you, drop a like and hit the subscribe button. It's the best way to show support so I can keep making massive courses like this for free. Check out the other videos on the screen right now to take your next step to building your career, and I'll see you in the next one.